The Earth is very flat.
What's going on, everybody? It is Thursday, September 16th, 2021. This is Brandon, host of Brandon's Show. Welcome, everybody. I see quite a few familiar faces in chat. Ian Adams, Gadget Inspector, PJ Cruikshank, Level Seeker, Alexander Lightwater, Arwin, Titty Bingo 33, Gadget Inspector, Greg T, page 42, and PJ was first. What's going on, guys? How's everything going today? Good. Let's see. What are we going to do today? I see quite a few people are probably over watching Jaren right now, but that's okay. We got a few people in the Discord. So I'm going to tell you about a conversation that happened last night in the Discord. It was pretty funny. And I don't know what else we'll do. We'll figure it out.
But it certainly is. It is a what do you call that? Inflated bubble. It's very much. There's very much built off the investments of speculators who are literally speculating on nothing. There's no value there. So, if I were you, I would take your earnings and slowly start moving them elsewhere. But relying on that to happen again and again and again is going to be your downfall.
Bro, my shit just ticks in. I don't do anything. Like, my money just ticks in every day, day after day. I don't do anything. Who's pulling out of that? Ain't nobody pulling out of that. People are trying to get in on that.
Why don't you get it on currencies?
I tried Forex before. I didn't do good.
Well, see, here's the thing. I think that you're high off of these immediate gains, quick gains, lucrative gains, and that is never a normal. That is never a regular thing. Like, that's something that if you were a part of, you got lucky, and you should count yourself lucky.
Bro, I make 20
lucrative gains.
Bro, I make $20 a day. This isn't like fast, get rich quick things.
$20 a day.
What's up, guys? We're live on YouTube. How's it going?
What up?
Jeremy's just talking about how he sucks dick for $20 a day.
I didn't say that. Fuck off.
Why the fuck you charge me 40, man? What the fuck? Let me say hello to everybody in chat. Blunt Raps, please. Chad, Conrad, Conspiracy Santa, DMOC, Enigma, Farming Ganja, Effie Walker, Jace, 711, Pete Shea, Jeremy, Pope Sin Cleanser, Reckoner, Seek and Find, and Bob Dole, the real Bob Dole. What's going on, guys?
You're darn right.
Your intro, I've been meaning to tell you for a while that it's so powerful. The images and, like, you know, the stuff you show, it really hits a lot of notes about what I talk about with Nixon and Vietnam and the space race. And
hell yeah, that was Adam put that together. Adam Meekin, he pulled that together for me. I picked the music and came up with the concept, and then he put the video together. So I guess it was a collaboration. Yeah, that's it. But he did most of the work. Shout out Adam.
It's like Jeremy's not the only one sucking dick today. Just kidding. It's Crit. But I asked a question yesterday that Crit answered, and I thought maybe I'd invite everybody, all the other specifically flat earthers. I'm not asking this as a gotcha, so I'll try to ask it in a way that makes it apparent that I'm not asking this as a gotcha. But a straight up question. I know that for me, if I was trying to determine the path between two locations on Earth, like let's say Seattle and New York, I wanted to determine the path. On the globe Earth, I would use something like a great circle, or I would determine the great circle. Thank you, Jeremy. But yeah, I could use Google Maps, for instance, and just like pick on these 2 points and then see what line is created and just use that. But that's kind of my question is, from a flat earther's perspective, if you were determined to have two locations on Earth, any two locations, and you wanted to know what the shortest path between those 2 points was, and not just know the distance, but know what that path was, let's say in order to find what locations were along that path, like what other cities or what else is along that path. What method or what tools would you use to determine the shortest path between 2 points, including details of that path, like what lies along that path?
Shortest path between 2 points on a globe or in reality? What are we talking about?
No, and just in reality. In reality, I mean.
Oh, okay.
Because I mean, ultimately, like if I was gonna be honest, I would just use Google Maps, and then I would find what the shortest distance was, and then you know you can make a line if you show the distance between two places. It draws a line for you, and then I would just use the locations that lie along that line and say, okay, well, this location's along that path, and this location. I'm just curious. Other than using that, because I'm sure everybody else would do the same thing. Is there anything else you could do to learn that information?
I'm curious, Kosho, how would you verify that it was accurate? Like if you drew your line, and then how would you verify that the things were really on that line that you're claiming that Google Earth claims are on that line?
Yeah, or just use state surveys. What do you think Google uses for half their shit? These already available surveys based on Cartesian coordinates. You think you're circling to get to where you're going to, Kosho?
Well, then I'll ask this question just to make sure. Then, so then, would you accept the path that Google? So if you were looking at 2 locations on Google Maps, and you just clicked on this location and this location, and it showed you the shortest distance, and it showed you that line, would you then trust that information then as the shortest distance and as the path? Like if I did like New Orleans to fucking Chicago.
You do realize that it's not a very big difference at all. Even at that distance from New Orleans to Chicago, it's not that big of a distance between the curved line and the straight line. We've already been through this, right?
Yeah.
Well, sure. I'm not trying to do a gotcha. It's not a gotcha or proof. Yeah. I'm just trying to see if that information that you could use it. I would use it. I would accept the points along that line were along the shortest path. So if I did like Chicago to New Orleans, and let's just say, I don't know, St. Louis was on the way, which I don't think it is. Let's say St. Louis is on that path, and Google Maps showed that. I would assume that was correct, and I would say, okay, I guess it is along that path. But I'm asking, like, is that something that you guys would accept as well? Like, would
probably
would
that
you
example you
believe
just
that?
gave, where it's in the same line of sight? Maybe.
Actually, very quickly, I've just left you a message in the chat. If you could have a look at it, if you can, that's cool. Sorry, I don't want to interrupt, guys. Many apologies. I'm off again. Thank you.
Oh, talking to someone else.
I'll just reiterate one last time. This is not a gotcha, and I'm not trying to prove one way or another. I was thinking about this the other day, trying to get.
I ain't trying to dodge the answer to it. What's your exact question, though, Kosho?
Do we trust Google Maps?
Well, not do you trust Google Maps, but let's say, for instance, you were determined that you were going to travel from Tallahassee to Los Angeles, okay? And you were going to take the shortest path, and that was you just want to know that path. And you want to see that, what's it called? Salt Lake City looks like that it's on that path. It's on that shortest path, like it's right on that line that's in between you and Los Angeles. And so this is what Google Maps says. Would you trust that fact, or would you use some other method to determine if that was on that path?
How would you take the shortest path? Since you have to either travel on roads, or even if you were flying, you would have to stay within whatever. You can't just fly directly. You're going to have to stay in some certain flight corridors or whatever. You're sort of asking like this hypothetical question that doesn't really, in practical reality, doesn't exist.
It is a hypothetical question, but it does exist. Yes, it does exist. I mean, there are how do you say? Like there are reasons why you would use a straightest path. So like if I don't know, like let's say telecommunications or something. Like if you were at some location, maybe in the sky, and you were pinging to all these different places, you'd want to know what the shortest is, or you would determine really what the shortest path is between you and some other point. So there are reasons why that would be useful. But yeah, you're right. It's not something that you would be able to practically show just by driving or flying or something. But
I'd say
yeah,
like
so
on
it's
major
just-
interstates, they're probably pretty accurate. They're probably a little less accurate in like mountains and shit like that. And over probably a little bit of but they're pretty fucking accurate. I mean, I heard that that Los Angeles is further south than like Austin, Texas. That was strange to hear. I mean, I don't have it pictured like that in my head. And look at this globe right here; it doesn't really seem like that. Is that true?
What latitude is Los Angeles at? What latitude is Los Angeles at? I'm in Austin, Texas.
Don't you consider yourself lower than Los Angeles though? Before we look it up, I mean,
I never really thought about it, but I would believe it if it were either way. I'd believe it if Austin was further south or Los Angeles. But honestly, I feel like Los Angeles would be further south. But let me look it up.
I do too. It just seems like it would be because it's warmer and shit.
34 north.
It's 34 north? Then no, it's not. It's not further south at all.
No,
It's
I meant
much farther
the other way around. I've actually meant the other way around.
Oh, okay. Well, yeah, if it's the other way around. Then yeah, Austin is further south, and it's kind of surprising a little bit. But yeah, it's like what 100 or 200 and I don't know 60, 270 or 280. Sorry, miles further south.
yeah, it's not
Actually, I'm using the whole wrong example, man. I'm just gonna fess up here, man. I botched that, man. It's a different example, man. Let me see if I can find it. It was pretty interesting. To two cities. There was one in California and one somewhere.
Well, I'll tell you, dude.
I know what it was. I know what yeah, go ahead.
Rome is further north than New York City. A lot of people don't know that, but yeah, Rome is
I think
actually
it's something
further north.
Nevada.
No, that one doesn't make any sense to me.
It wouldn't, but yeah, it's for sure.
I think we need to look into these maps. See,
I think it's
What's
Reno is further south than San Francisco. Shit, I forgot.
That's interesting. That's what's interesting about the equinox, because obviously on any given day you can use Polaris, but you can confirm the latitudes that you're given from Polaris by using the equinox and determining the altitude of the sun. And if you take the altitude of the sun at your local solar noon, then it should perfectly match your latitude, or the complement.
Hey, did you notice that the equinox, like they say, it's on like the 21st or 22nd? It's like I had to go all the way to the 26th to get it within 1 minute. There's no actual equinox where I'm at, but it was within 1 minute on the 26th. And also it shows the sun rising due east, which I went out to the beach and ran string lines, and it does rise exactly due fucking east. I will say that the sun split my hair, my string line. But
when you're saying equinox,
it still circles around though, and it sets due west coast show, but it still circles around. It doesn't come.
Yeah, of course. Exactly. That's what me and Jeremy were talking about actually, because we're trying to get a guy on the equator, because on the equator it will make a straight line. It'll start in the east, go to the west, like everywhere else in the world. It'll make a straight line.
Gosh,
everywhere else, you're right. Still, it starts in the east and goes to the west, but it makes a curve in the sky. But when you said 12 hours,
I showed a perspective how that happens. How
if
something's doing a ring out to the right. Yeah, go ahead.
How can it? Okay, so you're saying when it's north of you or when it's south of you, it looks like it has a circular path, but on the equinox,
okay.
Hold on, I didn't get my question out. That on the equinox, it doesn't look like there's an arc to its path. So that's weird, isn't it?
No. On the equinox, there still is an arc to its path. So everywhere except for the equator, it starts in the east and goes to the west, but it'll go in some degree of an arc depending on how far from the equator you are. But at the equator, it goes in a straight line from east straight west, and everywhere further from the equator, it'll that curve will be more extreme. But it still starts in the east and ends in the west.
Oh,
Picture this,
Brandon. Just on the equator.
Picture you're on the equator, right? Picture you're on the equator. You're not looking north. It's due north, okay, in the first place, where the sun comes up. Now picture it circling off to the right a little bit. Okay, it's gonna do a semi-arc. Now picture a person on a piece of paper at the bottom of the piece of paper. Picture yourself a horizon like in the middle of the piece of paper, and then picture a sun right above the horizon. Okay, off to the right, like it was circling. Then draw a sun halfway higher up the page. And then draw a sun at the top of the page. So draw like 3 suns. You got a closer angle to the one at the top. Just by going up, it naturally gives you less arc. I mean, in other words, as it circles, as it comes up, it actually straightens itself out. I got a little video on that, not too far back.
Let me say greetings to everyone and say synchronicity is amazing. Would you believe, Brandon? How you doing, by the way?
Hey, what's going on?
I was about to join and raise this very topic. I was about to present, definitely the co-show specifically, this very issue. So that has been talked about now. Amazing, amazing. So let's mull over the possibilities, if we will, in an intellectual sense. So we have equinox, right? We have someone standing at the equator. We have someone 1,000 miles south in Australia, 1,000 miles north in the Philippines, right? We're all looking at the same phenomena. What options do we have? And it's very, very interesting. I will add more later on, because we're confined by the certain option that we do choose. If we choose to be on a ball Earth, if we choose that the ground is contoured, then we're confined by that immediately in terms of what we have to say the sun is. So that's very interesting. I'll just say hello to everyone, and yeah, good to hear this.
Yeah, hey, what's going on, Pete? So what was the point of you asking us about the distances, Kosho? Just out of curiosity, what do you said it's not a gotcha.
Oh, you mean no? I'm asking about the points along the straight path.
Yeah.
You mean yeah? Because ultimately, I'm actually doing a test. I'm doing a test with Joby and with B-Baller, and that test includes taking their positions and making a straight line, given their 2 positions, and then finding a point along that straight line. And so on a globe, I could do that mathematically, or just with some effort. I can find, okay, he's at this point, he's at this point. What's another point along that path? Along the shortest path between them. I can figure that out. I also could just use Google Maps, like I said, and just like take their 2 points, see the line, and then see what line, what's on that line. And I was just curious.
I took a laser.
What flat earthers would accept, or even how they would accomplish that same.
Have you set
same effort?
Kosho, have you set the parameters for the globe? So you say on a globe, but you've said what the sun is and the distance to the sun, right? That you can triangulate. And you also said you talked about the constituency of the sun. So it's a solid body that you can do trigonometry on it. Is that correct?
No.
Okay.
Look what I did. What I did, Pete, is I went and got the globe, right? And I set up a laser and leveled it out at 0 degrees and put the laser away from it about 20 feet. And I got a spotlight and with a little bit of a consolidated beam, but still, I had that a little bit closer than the laser, okay, on the globe, propped up. And then I went through the seasons, and you can see the hot spot, and you can see where the laser's coming from. And I found out a few things, man. I found out there's a few things you could question about flat Earth models.
You're not going to do it, JB Brown.
Don't let me in there, buddy. I mean, there's a few things that didn't work on a globe.
Okay,
the sun does not come in. The sun does not come in from the south on a globe in Australia. Period. At best, I was able to manipulate it a little bit and get it to come in like half of that motherfucker south of east. It just doesn't work on a globe, but in reality, that's what we see. And I don't know.
In reality, Brian, in reality, there is no east. There is no east. Everything is in relation to the north. That's why there is no south in flat Earth. Now, Kosho denied something, but he's going to have to go back in his word here. because you have two options, right? This is why I was going to come in with this scenario, which is brilliant because it encompasses everything. So, on the equinox, and we can all agree to observation, this is what we're trying to figure out. You have a guy 1,000 miles north and 1,000 miles south. We're all observing the same thing. And when we're trying to figure it out, what are the possible scenarios? What are the possible settings that we can sort of lay down? And we can, first of all, state them. Then we can whittle them down. If they don't stand up to scrutiny, then they have to be discarded. So this is the possible setting, isn't it? And you mentioned a globe. On a globe, these things will predict a certain way. That's fair enough. This is one option, right, Kosho? We're about truth here. The other option is on a flat Earth. Now, here's the stipulation, though. Here's the necessity, actually. On a globe, because we're observing the sun, we have to say that the sun is far away. You have to say that. Actually, you definitely have to say that because you're basing the foundation on the conclusion, right? You already know, you've taken the measurements. Now it fits with the foundation of thinking. You've clarified it that way. But fair enough. Now go the other way. Now you have to admit, if we're on a flat and planar surface, then the sun cannot be of the same kind that as associated with that level of thinking. It has to be near, and therefore it cannot be solid body. So trigonometry cannot apply. You understand now?
Let me finish.
Now you have to define.
I think it's the opposite.
Let me finish my point, y'all. Okay, so the point is when I was set up that laser in the spotlight, okay, it didn't work in Australia, and I was able to manipulate it. Then I talked to some Globers, I think it was Stingray, it was on the episode, and he, so they're like, they tilt the sun. So bring the sun up from a certain angle, okay? And it worked, right? But then you don't spin the globe if you tilt the sun. Then you got to rotate the sun around it at that same angle. Yeah, it works in one spot. If you tilt the, I want to say if you tilt the Earth, okay, it works. But then if you spin the Earth, it doesn't work anywhere else. You just fuck up the whole rest of the Earth, and it works right there where you tilted it to prove your point. But that throws off the whole. God, I wish I could explain this. In other words, if you tilt the Earth, you don't then spin the Earth. To make an example, if you tilt the Earth, then you got to orbit the sun around it at the same angle that it's supposed to go. Because by tilting the Earth, you're throwing off the whole fucking orbit. You're no longer the pole is no longer facing Polaris. So that example use is it's trickery.
Wait.
You have to imagine.
What do you mean? What do you mean it's no longer facing Polaris? It tilts in the same direction in the model, right? It's just the different side is facing the sun. The side that's tilted forward, the side that's tilted back, or the side is facing the sun as it goes around.
Right. But here's what they do: they tilt in computer programming. They take and they tilt the Earth, and then spin the Earth. That's right. Try that. Just try it. Get a fucking globe. I said I can't explain it. Whoever's got a globe, out there, try and do that. It doesn't line up anywhere else.
Data made this point a while back. I remember Data brought this up, and he made a video. And I honestly, no offense to Data, I could never understand the point he was making. I watched it a couple times.
I'm gonna make a video and just show you better how to explain it. Instead of trying to explain this, I'm gonna show it. And
okay. Yeah, but Brian, if you had a cul-de-sac and you imagine the cul-de-sac was the fucking orbital plane of the sun, and so the cul-de-sac's the street, and then you had some object way far away in the sky, so far away that it's just stationary there in the sky, but it was from that plane of the cul-de-sac, it was 23 degrees angled away from where the cul-de-sac was angled at, and then you had some object, we'll call it the Earth, that was going around that cul-de-sac. All you'd have to do is you'd have to tilt that object pointed towards so the object on the cul-de-sac pointed towards the object in the sky, 23.5 degrees, and then keep it pointed towards that and have it make circuits around that cul-de-sac. And if you did this, then no matter if the object is spinning, no matter what, it's always the north part is always pointed at that object in the sky, and it's just, it's just not lined. It's not oriented the same way as the cul-de-sac. but it's always pointed
Okay.
at that object in the sky. So
And the north axis is always supposed to face Polaris, right? It's supposed to always face Polaris. Okay.
I didn't
Yeah,
know what
right
a
now,
cul-de-sac
yeah.
was.
No matter what way the Earth is tilting,
From the
the North
start.
Pole. Hold on. The North, no matter what way we tilt the Earth in a globe, it's always facing
No.
Polaris, right?
no, as long as it's
The
tilted that
North
way,
Pole-
right. No, but right now it's tilted towards Polaris. It's going to stay tilted towards Polaris for a very long time. So the Earth's not changing its tilt at all. It's just orbiting.
Yeah,
It's just orbiting around.
it's always
the
tilted the same amount.
So it's always
Yeah.
facing Polaris. That's my
Zero.
question. So if it's always
Hang on.
facing Polaris, and I have it set up in the center, if I have it set up in the center,
Hang on,
wait,
Brian.
that's my whole
This is fair
point,
enough.
bro.
Yeah, but
If I have-
this is
Brian,
fair
hey,
enough. We
hold on a
can't-
minute. Hold on, Pete. Brian, your mic is getting horrible feedback or something. I don't know what the hell the problem is.
But also, it's not a good area to sort of venture into how experiments might sort of turn out. A better sort of area is to deal in the intellectual here. We're trying to fathom in our brains what may happen. So, Kosho, that's fair enough. Do you understand that if you place yourself on a flat and stationary Earth, that something also might be countered, which is the sky. Remember, we have two observers 1,000 miles and north, 1,000 miles south of this equator. They will observe the sun and equinox at a very specific point. They can have each other on Skype or whatever. So they'll observe a very specific degree, which will be equivalent for both. Now, what's the flat Earth scenario? This is where you have your limitations. With a ball Earth scenario, fair enough, you've developed it, right? It's a possibility. No one's denying that. It can be tested. Let's see how it adheres to the possibility. What's the flat Earth scenario?
I think the point though is that there isn't really a flat Earth scenario. That
But
makes
hang on,
sense.
you're a scientist. Develop one. You've been fucking doing this for 5 years. Develop one, and you're set by. Sorry, for my shouting. I'm pissed off at that comment. But hang on, Brandon. This is my point here. Once you set yourself in a flat Earth,
why did you just start talking?
Once you set yourself in a flat Earth, bud. Once you set yourself in a flat Earth, then the stars become something different. Are you saying there's no scenario there that will encompass possible reality?
I'm saying the only one that I have come up with is that somehow there is a second point around where you see a bunch of rotations of stars that somehow seems to be moving, seems to not be
There's
moving,
three of
but
them.
it is moving.
That's the best
Hold
your
on.
brain can do. Is that R.C. Meisty, is it? Who teaches the children?
I'm just saying I have never been able to think of a scenario where you can have two seeming points of rotation in the sky.
I'll give you one right
that
now.
seem to the
No,
all-
RC Meisty the pilot, man. It's
I'll give
RC
you one
Meisty
right
the
now,
commercial
you
pilot.
Hey guys,
Why is
we-
everyone
hey,
screaming?
let everybody
I'd like
finish.
to know.
Children.
Sorry to interrupt, but let everybody finish talking, and we got plenty of time.
Okay.
Yeah, what I haven't.
Children, though. That's why I'm pissed
What I
off. I
haven't-
give them a scenario right now.
All right, so the scenario that I haven't been able to really understand is how you have 2 points of stars that are seemingly rotating around 2 different points, yet everyone looks in the same direction to see those no matter where you're standing on Earth. Now that
Okay.
I haven't been able to fathom a
Okay,
flat
forget about
plane
that for
where
a second. Remember the
Can
scenario?
I please
Okay, I
finish
got
my
your point.
sentence? I
haven't been able to fathom that.
Pete, why are you talking?
Hold on,
over me?
Pete.
Because you
Let him
made your
finish.
point. Okay, Brandon, he's made his point. That's not the
Yeah.
scenario offered. That's not the
Go
scenario offered.
Oh my gosh!
Okay, finish your
Go
point.
ahead,
Off you
RC. Try to keep it more concise, but go ahead.
I literally hadn't spoken even for 20 seconds.
Okay.
So my entire point is I haven't been able to fathom a scenario where you actually have 2 different points that people are looking at the same direction in, yet they don't seem to move ever. Yet on a flat plane, that seems like they would have to move.
Right. So I got your point already, but if you want to deal intellectually with the scenario presented, as we perceive reality, right, at equinox, one guy is 1,000 miles south of the equator, one is north of the equator, in a direct line to one another. They perceive the sun at midday, a specific point, at a specific angle, right? Now, what are the scientific scenarios presented? There's only a few possibilities. Remember, if you choose that the ground is curving, you have to choose that the stars are far away. You're limited by that intellectually. Now, if you choose that the earth is flat, then you have to choose that the stars are near. And that means that both models are completely separate from one another, and what the stars are said to be have to be necessarily different. Forget about everything else. How can you answer that?
Okay, I've forgotten now about everything else. Tell me.
Forget about Polaris.
All right.
Forget about what anyone else experiences anywhere else. We're dealing with a scenario.
All right. Great. Cool. We're at a scenario. I forgot about Polaris. I look up in the sky.
For the moment.
Right. I know. Pete, thank you.
What about the sun at equinox? You understand that?
You look up in the sky. You look up in the sky, and all the stars are moving east to west, right?
Yeah.
No.
Then I get to a point. When I get down to Argentina, where number one, I can't see that the point that I was seeing before. I see another point that doesn't.
Have you been to Argentina?
Yes.
No, but the answer to Jeremy's question is no. They don't move from east to west.
Listen, why don't you stick to scenario
Which direction do they move?
like a
Hold on, Pete. Which direction do they move?
Depends on what stars you're talking about, but they go in a circular fashion. They don't move east to west. Some move east to west. Some move north to south.
Don't worry
some
about the
move south to
stars.
north.
We're worried about the sun. We're worried about the sun at this particular scenario. Why are you going on to a different thing?
No, Pete, you changed.
All right, go ahead, Pete.
No,
why are you scenario? So RC Meisty, what is the flat Earth scenario? You understand that you're limited by near stars, right? Because we can all equate by moving from the position of the guy north of the equator to the south of the equator that we'll perceive a differential in the apparent location of the sun.
Yes.
You understand that? That means that it has to be near on a flat Earth scenario and it has to be far on a globe Earth scenario. Now we got to decide as living men, because we want to pass on the truth to our children, what is the appropriate scenario? What is the nature of our reality?
We actually don't observe that they're in a different position. We do observe, for example, on the moon that it looks upside down from when I'm.
What do you mean?
America.
What do you mean we don't observe when the guy at 1,000 miles north of the equator is looking in a completely opposing direction to the guy at 1,000 miles, and they're looking at a central point at the sky?
Yeah, and one of them looks upside down to the other.
What do you mean one of them looks upside down?
Yeah, if you look at the moon in Australia versus here in North America, or as my case, I looked at it in Argentina, it looks exactly upside down.
Fair enough. If I'm looking at a drone, right, and it's equidistant between me and you, we're both looking at the same thing at a different angle, but we're not upside down.
Okay.
That's the opposing scenario. Why do you object the obvious scenario? I'm not telling you what's what. I'm asking you to develop both scenarios or both possible explanations.
I haven't been able to.
Why not?
Because
have you been able to understand that the stars might not be far away and therefore there might not be material bodies?
Because I run into blatant contradictions in...
How the fuck? When you look at the moon in the daytime and you see through it, maybe it's a fucking reflection or something.
What's the contradiction?
Telescopes. Okay, I'm sorry, man.
Well, let's hear the contradiction, Pete. I'd like him to follow up with that because I think you were on a.
Okay, I'm sorry, man.
Good. No, you're fine. RC, you said you ran into blatant contradictions. What are they?
I want to force him to present both scenarios.
Yeah, no, I get it. I get it.
Possibility.
Okay. Yeah, one of the specific contradictions that I see is, first off, as I look up, I see like I don't see the same thing as somebody else who's 1,000 miles south of the equator. I see something different if I look in the same direction. Yet, especially on the rotation side of things, if I assume that the stars are rotating above me, I go from Argentina over to Cape Town, South Africa, and I still look in the exact same direction to see the point that the stars are rotating in the sky. And same thing if I go to Norway versus Canada. I see another point in the sky that doesn't seem to move.
How's that a contradiction, though?
Because how can you be?
The scenario is someone who is north and south of the equator, right? They're in one parallel. They're on the same. They're on the same longitude. If you want.
Can I respond to his question?
No, because you're switching.
All right. So
I'll give it back to you right after he answers this, Pete. Go ahead, RC. How's that a contradiction?
Yeah, because if I am standing under something that is rotating above me, and I look in the same direction, I should be able to see different things than if I were standing on a flat plane.
When you presuppose how the sky works.
I don't understand why you think that.
When you presuppose how the sky works.
What are the stars on
I'm
the
not
flat plane? You
presupposing
just
how the
agreed
sky
that they
works.
have to be near, so they
I don't
can't
know
be
why
I'm just
peripheral.
simply saying if I'm standing on a flat surface,
What's nice
and
says
I'm
I
looking up
should do this.
if I'm standing on a flat surface and looking up at the ceiling, right? If I look at the same direction, I should see the exact same thing.
Look at
Right?
star trails, wow.
Stars in a flat plane.
Feisty, look at star trails, buddy. You do see different things. At the equator, you see the stars going straight overhead, and then off in the distance,
Tolerating
if
this
you're off to the
guy.
right.
Hold on.
I see, Meisty. Why can't you answer a straight question? What are the stars in your flat Earth scenario here? Are they the same as in your globe Earth scenario?
I don't know.
Because logically and necessarily they cannot be. Do you understand that?
Why would logically and necessary they cannot be?
Am I the only one? Am I fucking stupid here?
Yes, you are. But
okay, let me tell you how I'm not stupid then. Let me tell you how I'm not stupid. Because as you walk away from Polaris, right? We notice this is in your terms now, we notice a 1 degree declination with every 69 miles. Is that correct?
Yes.
Right. If that was on a flat plane and Polaris was at the similar distances, could that work?
No.
Right. So therefore, distant stars on a flat plane cannot work. Would you agree?
Sure.
Right. So, on a flat plane, which I have myself in my mind on, the stars cannot be far away. Would you agree?
Sure.
Right. So, what the fuck have you got the stars as being on this close encounter?
Close together. Close to me.
Have you got them being spherical bodies, whatever, flaming?
No, I have the. You just said it.
You can't have them at the same size, right?
Yeah, you
have to change the size of them, right?
Pete, I just told you, if I'm on a flat plane, according to you, they're very close to me, correct?
Right.
Okay,
so the sun cannot be
a
million miles across.
So if they're very close to me, right, and I ask myself, if my angle changes 1 degree per 69 miles,
right,
then I know exactly how high it should be if I know exactly how long I am away from it, correct? And I know the degree to it.
No, because you have not followed. Hang on, please. I said no, and I say because I'll tell you exactly why. Because when you admit that the stars cannot be far away on a flat Earth, you also have to admit the stars cannot be the size that they are on a flat Earth as they are on a globe Earth. Would you admit that?
So you have two.
That's a question.
Angles. Yes, I do know that. And so if you have two angles and the distance of one side, then you know all the other things about a triangle, right?
That's solid body trigonometry. This comes to my next point.
Yeah.
If the stars are not on a flat Earth scenario,
that means
same size. Hang on, please. If they're not the same size, the same distance, are you asserting that they're the same constituency?
Say it again.
Are you, if they're not the same size, which you admitted on a flat Earth scenario, if they're not the same,
distance,
so hang on, I said it again, and you're interrupting me. If they're not the same size, not the same distance,
said yes. You're
are
right.
you asserting that the needs must be the same constituency because you will need solid bodies to do solid body trigonometry?
I didn't say anything about them being solid bodies or not.
You will need solid bodies to do solid body trigonometry.
What is solid body trigonometry?
You work it out.
Euclidean geometry. So this is what I'm always harping on about your Polaris model, how you think it should work on a flat Earth. And I think Pete is making the point that why would we put forward that model that you guys say falsifies the flat plane? We wouldn't, obviously.
I didn't say you did. I'm actually just listening to Pete, and that's what he's telling me.
No, I'm forcing you into a corner. I'm forcing you to ask in a scientific sense.
I'm just following along with what you're saying.
Stop interrupting me. So if you are, you've already admitted in a flat Earth scenario. So remember, we don't know the answer. We don't know the answer. So we presented a scenario. Now, well, hang on, please. If we already know the answer, what's the point in us talking here?
Because you're just blatantly contradicting yourself here. You're saying, wait a minute, we have to intellectually engage with it, but we don't know the answer. Here's my next question to you. Can we know the answer to this?
Yes, we can.
Okay, cool. How do we
Are you willing to stretch your mind for a basic consideration? Excuse me, please. Are you willing to stretch your mind for a basic consideration? Brandon, This guy is a fucking. You know this guy's.
I know. Quit interrupting Pete.
Yeah,
man.
he's
Finish my
getting to you,
sentence.
Pete. Don't let him get to you.
Quit interrupting
I'm
Pete.
Let me
saying
finish my
yes.
sentence, then.
I'm saying
Let me
yes.
finish my sentence, then.
I'm saying yes. Pete.
Right.
All right. Tell me how it works then. How do I get to know?
I'm not telling you how it works. We don't decide how it works. Remember, I said tonight was a mental exercise.
No, you said
Right?
that we could know.
Imagine we didn't know the
I'll tell you
answer.
how it works.
But
Okay,
all we could
drop
do was
about
base our
69 degrees
real
Oh.
experiences.
I mean,
The
69 miles per
declination I'm
degree, we
trying to
know
get
that.
into-
Hold on, Brian.
We know what we
Brian.
see, Ignace.
Listen, the declination I'm trying to make here is that on a ball earth scenario, which is offered as a possible solution to our observations of reality, right, that we can all agree on, I'm not denying that. I'm saying, fine,
okay.
that's a developed model. That's a possibility. Now I'm asking you to consider the flat earth side, RC-MIC, and develop
Okay,
that somewhat.
tell me about
Because
it.
remember, we don't know the answer. We could
Yes,
be right.
we do know the answer. And the
I think,
answer
uh,
gives you
Hold
context.
Hold on, before
Whoa.
we get railroaded down
Hold on.
that path, I just want to point out that I do think that Pete has got a point here. And what he's
Okay,
saying
what's
is,
the point? 'Cause I don't
so
understand the
often
point.
hold on, let me finish. So often from the globe side, we hear these lame falsifications. It's like paper thin, skin deep thinking about the possibilities of, if we were on a flat earth. So you run into this one problem and you say, well, that falsifies it, so that's ridiculous.
No, I didn't say it
and never
falsifies it.
explore these further
Mutually-
options. So I think it's an interesting line of thought to go on is, how would I try to establish, how would it work if the earth is a flat plane?
Can't-
How would this
Okay,
work?
so
Assume that's
so
true.
Brandon-
It can't work.
Assume
So
that's
Brandon-
true, and then explore it.
So, okay,
Brandon,
Brandon.
they're
So I've been.
mutually exclusive.
Pete,
Hang
you've
on,
been
Rumpus.
talking
They're
for
mutually
10 minutes
exclusive. A
straight.
globe Earth
Can I
has
at
to
least
consider
say a damn
far
sentence?
distant stars. A flat Earth has to
Seriously,
consider
though.
near
Brandon,
stars.
what the
And
No, we
hell?
get
they
it,
have to be
Pete.
of
Hold on.
different
Let
composition.
RC was going to respond. Go ahead.
So that is why I'm trying to say, okay, I have now erased everything I think I know about the globe. All right, done. It's gone away. It's in the trash can. Now my question is, how do I go? I agree. Okay, now we need to find a new way to explore it. But I'm asking,
Okay, go
can you at least
if
give
you
me?
want models.
Stop, Pete. Can you at least give me 2 or 3 things I can do to try to figure out what it is then?
Yes.
Just go to Steve Torrance and look at the model. What we know is what we
Hang on,
see in
Brian.
reality. The stars drop about
Yeah.
1 degree per 69 miles. What we see is what we get. And up to them, Pete. Up to them. You don't even see the stars when you
listen
get
to
up
this.
there.
Listen
Their
to this.
whole their
Listen to
model
this, though,
collapses by
Brian.
their own words.
Does
Yeah,
does
listen to
anybody?
this, though. Listen to this. These guys, hang on, please, RC. Hang on, Brian.
So
These
tell me,
people
is there
claim to
anything I
have-
can do
Hang
to
on, please. You
investigate?
claim to have a sort of grasp on the truth. When you're asked to imagine all manner of fucking things, you're asked to imagine, beyond the solar system, the greater galactic fucking center and greater movements, and the greater cause to these greater associated movements. And you easily accept that, right, in your brain, but you cannot, after years, Rumpus, this is to you especially, after years in this arena, you cannot imagine a associated scenario with the flat earth with certain logical necessities. You cannot even paint a basic picture of that side of things.
No, I'm
Are you a
asking.
science man or not?
No, I'm asking you to freaking just show me how would I do that? Because I agree with Brandon.
tell you.
actually. Hey, stop.
I'll tell
Pete,
you.
stop. I'm in the middle of a sentence, you dumbass. So I'm asking, just like Brandon, I've now erased everything. Now it's a good question. So how would we imagine it? Now I'm not asking you to just keep asking the question over and over. Can you give me 1 or 2 things shut up.
Yes.
Can I give you 1 or 2 things that I can do to investigate that?
Yes, I can.
So give me 2 or 3 things.
Right, you said 1 or 2 first of all. You changed your mind for 2 or 3. I'll give you fucking plenty
Okay,
more
okay.
than that.
Give me 1 or 2.
Right, to consider, for consideration, right? For consideration, we live in a world, hang on, let me finish. We live in a world of opposites. What's the opposite of empty space? Heavy cold waters. So it's cold waters beyond in the flat earth scenario, right? Everything is much more up close and personal. On a flat earth, stars have to necessarily be close. That means it can't be material bodies. If there's waters beyond, and if there's some sort of barrier, energized or whatever, we know water is reflective. So maybe all the skylights are stars and are all reflections. And if we consider an atmosphere as well, we have to consider that we're looking at reflections moving, but through an atmosphere of gradient densities, right? The further out they move from our relative position. Now we have to consider. Now we have to consider if the Earth is stationary, perhaps there's a singular source to all of these
please don't ever tell me
That's
that
about
I'm
6 considerations, and you interrupted me. I'm done now.
You asked him for. As far as I know, he's answering your question, RC.
No, I said, can you give me 1 or 2 things I can do to investigate? What can I do?
Hey, what you can do is go get you a fucking time-lapse camera.
I can't hear you.
Okay.
Talking through a fishbowl.
Get you a time-lapse camera. Okay. Go look at the stars.
I can't hear you, Brian.
Can everybody else hear me?
No.
No, it's pretty bad. It sounds like you're talking through a pillow.
So that,
I'll tell you what you
Brandon,
can do.
do you
I'll tell you what you
agree,
can do. Exactly, man.
you
Always
agree,
forget. Here's
Brandon,
what you
that,
do.
do you
All
agree,
right,
Brandon,
I
that he didn't tell me what I can do? He just gave
Yeah,
me
here's
an
what you
idea.
can do, man. Stop and listen what you can do, Meister. Okay, what you do is you get your time-lapse camera. Go do star trails, okay? Travis just did a demonstration on his channel on the Plain Truth. Look out in the distance, okay, how the stars deviate off to the right, out a little above the horizon, and they deviate off to the left on the left side, and the one straight ahead goes straight ahead. That means there's 3 separate star rotations, man. We'll never know because we can only see one part of the night sky. But look, in your model, the stars aren't even visible when you get up past the Kármán line or whatever. Your astronaut, your first astronaut that went to the moon verified that, and when he said that we can't see stars, he don't remember seeing any stars up there. So we don't know that they're solid objects. That's what Pete's saying. We don't. They're not solid objects. Your own priests have verified that. They're fucking apparitions, man.
Okay, so I'm asking again, Brandon. Are you agreeing with me here? I've asked twice now. Give me 1 or 2 things I can do, and all they've said is imagine this.
Yeah, no, I agree. Hold on, I agree on that point. I agree from that perspective, but Pete did, say in the beginning, for your consideration. He was just he prefaced that that's what he was doing, and I think that it gets to the heart of the point is, there are other possibilities that we may not consider.
What I'm asking is like,
containing the other only possibility, which is a flat Earth and near scenario.
Pete, shut up for a second. So, Brandon, all I'm asking to do here, okay, is like Brian almost gave me a thing I could do is look at star trails. I was like, okay, cool. There's plenty of pictures of star trails that I can look at.
Measure the deviation, Meisty. If you want to do something, measure the deviation. But see, look, it does just like the sun. Hold on. In the northern hemisphere, we see the sun like go off to the right, just like the stars where I'm at. They go off to the right. In the southern hemisphere, we see the stars deviate off to the left, just like the fucking sun does in the southern hemisphere. At the equator, we see it go over straight, just like we see the stars go over straight. But you got a different perspective to it because we don't see the sun or the stars. They look like they're going just in a path as we're filming them. But if you look at the time distance or the long range, whatever you call it, time lapse, then you look off toward the horizon, they're veering off, and they're veering off away from each other. So that kills your model right there, bud. They're veering off.
All right. Those are observations. Brian, you just listed some observations. RC, I get it's a good question. How could we figure out what the stars actually are? That's I have no fucking clue, man. We'd have to go up there and see them, right?
Oh man, only if we had.
Well, I mean, if you trust the government, that's fine. You can take their word for things, but
no. But Brandon,
I'd rather do it on my own or get it from an independent source. To be honest with you.
No, but Brandon,
he's a thinking man, Brandon. He can entertain other thoughts. Can't you, RT
Shut up! You just talk incessantly. So, Brandon, the only thing I'm asking to do here is like I am 100% willing, and I want to show you that I'm 100% willing to go down whatever rabbit hole we want to freaking go in terms of the ideas that we can engage with.
Okay, so give us other possibilities what the stars might be.
Hold on, Pete. Fuck.
Okay, well, come on though, Brandon.
Shut up, Pete. And so my only question, my only request is, after we've gone as deep in the rabbit hole as you want, as far as you want,
You're being a sophist.
What's the freaking evidence
right,
that
so
where we are in the rabbit hole is somewhat real?
Say nothing.
Hey, RC, how many times did you need to say rabbit hole in order to poison the well on that response? And how many times are you going to make this little argument that you're making about you guys won't tell us how to do it? You're not telling me how to figure it out. We're saying we don't know what the stars are, but we're also saying your falsifications of the stars can't be local and over a flat plane is bullshit.
Okay. Why?
And now I think hold on, let me make one more point. Pete made an excellent point earlier, which was you swallow all this shit about the heliocentric model, like the bending of space-time, fucking things being 426 billion light years away or whatever the fuck it is. Light traveling forever and being able to time travel by going fast enough, right? You swallow all of this stuff happily. But we can't even get you to consider anything beyond, we can't apply Euclidean trigonometry to site angles when we look at Polaris. Therefore, we can't live on a flat Earth. That's the point.
That's not what I said. Brandon, hold up. That's not what I said, Brandon. What I said was, all right,
the universe from his armchair.
So, Brandon, what I said is that if I accept your premises, if you think I'm saying something bad by saying the rabbit hole, fine. I'll just say, if I accept your premises, all right, which I have, then I will just simply ask, how do you know, can we verify anything inside of the premise that you just built? Is there any evidence that
can you verify anything about the premise that you hold previously, and you're comparing everything else against that we must present to you a fucking waster?
Logic.
Fuck off.
He wants us to beg the question, basically.
No,
that's what he's asking us to do.
Can I just step in? And can I just step in?
Gracious reasoning, brother.
Hello, can anyone hear me?
Yeah, go ahead, Gleam.
Yeah, can I just step in and back up Brian Leakey? He actually gave you a citation earlier. I don't know whether it got lost in the argumentation, but I just tagged you in it in the general chat, RC Meisty.
Great. I would love to see it. What's it telling me?
It's a model from Steve Torrance.
Conversation revolve around this guy when he can't answer. If you can't answer a straight question and present both sides of the scenario and you're thinking, it's like a debate team, Brandon, in college, right? Well, what are you going to say when you get the debate side that you're on? Oh, well, I only debate once. No, you won't. You'll fucking present the best you can at both sides, and let's see which way is up the best. You can't even fucking, you know what I mean? He has nothing to say about the other side, even though I just proved logically, if Rumpus is here, let him join again. Yeah. Logically, necessarily, it has to be a dichotomy. Spinning ball Earth.
It's not.
Hang on, Rumpus, let me finish. So this is the dichotomy, and let me tell you, let me give it to you, and then please answer. So dichotomy, spinning ball Earth, distant stars, forget about the constituency, whatever they are, but flat Earth, near stars. You have to have your foot in one of those camps, your feet in one of those camps. There's no mixing.
Yeah, and we can invalidate the flat Earth scenario because, for instance, the moon, for instance.
No, forget about that. You're going into depth.
No, let's go for the moon, because that's the thing about the moon.
Dichotomy valid?
No, it's not, because we can invalidate the near star scenario that you're describing. For instance, the moon.
Talking about that.
Let me finish my point, Pete. If you want to go for a near star, near moon, near sun scenario, we can look at the moon, and if it's near,
the moon, Rumper?
Can I please finish my point?
Know what the moon is.
If you have,
Let him
so
finish.
if you look at the moon, oh Jesus! So if you're looking at the moon, let's say it's somewhere on the Earth, then you can then see the Earth on the flat Earth. You'll be able to see the other side of the moon. You cannot do that.
Oh, see, that's the kind of falsification we're talking about. That fucking skin deep bullshit falsification that you guys bring in here. You have no fucking creativity. You'll swallow fucking heliocentric swill all day long, and you can't even consider another alternative.
Pete Shea's trying to get on the fucking nuts of this bullshit. You hear Pete Shea's just throwing it out his ass. It has to be this way or that way. And
has to be.
Can I
On a
just
flat
Flat Earth,
admitted
you will be able to see
dichotomy. If you're on
both
a
sides
globe
of the
Earth, the
moon.
stars
You
have
No, can I
can't
just-
see that. Therefore,
Rumpus.
the near moon is
Rumpus,
not
look in the
possible.
chat, you're wrong.
Therefore, the near stars are not possible.
You're wrong.
Therefore,
Look in the
the
chat.
near scenario that Pete projects is
You haven't done it.
invalidated. So we
Hang
don't
on, I
need
can
to
even go
consider
further
it.
and tell you who
Okay.
I've
Well, then
given
just
the
go on
idea
mute because
about
we're going to
this.
consider it.
I know. He won't
Well,
even give the
validated,
alternative
okay.
idea. He'll just say this reality does not comport to a flat Earth, but he won't name all the constituent parts of the flat Earth.
Pete,
He'll
can I
assume
not-
that the moon is a solid body.
Can we let
All
Gleam
right.
have a word? I mean,
Yeah,
he got one full sentence.
let's hear what Gleam has to say. He's got a diagram here. Pete, I think you've made your point quite well. Go ahead, Gleam.
Yeah, if you put it in, it's the same triangle that Pete was on about earlier. It's the same as drawing a 6 and a 9 on the floor. Someone can walk up to you, you've just drawn a 6, and they can say, oh, nice 9. And you can go, that's not a 9, that's a 6. And they go, no, it looks like a 9 to me. It's the same thing. And for Rumpus to say you can see the other side of the moon, which is 4,000 miles up. How big are you, Rumpus?
I think he dropped.
Okay. Well, he's not that big. I've done it from Sydney to Japan, which is 5,000 miles, based it at 4,000 miles high, and I even done it at a small moon, so it's 32 miles, which is the worst case scenario. Steve actually puts it at 40. But at worst case, it would be 8.3% different for each viewer.
Yeah.
And
Hang on.
And if you knew anything, wait there, hang on, I haven't finished. If you knew anything about spherical distortion, you would know that the majority of the distortion is in the edge. So
And
all
that's
that
exactly
would be
where we
compressed
see the
anyway.
distortion, Gleam.
Yep. Great
That's
point,
exactly-
Gleam.
If you look at the moon, check this out, people. If I was just looking at the moon last night through my camera, and I was looking at videos in my camera that I'd previously recorded, and on some sides of the moon, this is true shit. I was just looking, I was wondering last night. You see craters like at the top right-hand corner, and then the left side of it and the bottom side during a full moon, it looks distorted. You can't see no craters. It's just all atmospheric-y looking when you zoom in and shit.
It's
You
a
don't see no
reflection.
bends and
It's a
bumps.
reflection of solidity, Brian.
It
Hey,
could be
Brian.
spherical, and you're looking
Hang
at
on,
things like
hang on,
shadows at
Rumpus.
different
Brian,
angles.
hang on, Rumpus. We're
Rumpus,
dealing with reality.
Rumpus, look
Brian.
at Rumpus, and hold on, one more thing.
What the heck?
Rumpus, go analyze the moon, but look at it real closely. Look at somebody who's zoomed in all the way around it and everything, and you'll see what I'm talking about before you
Brian,
comment.
you just deny everything.
And you can see it's a
Let me-
spherical body
One
because the
second,
shadows on
Rumpus.
it are different angles. So you
One
know
sec-
it's a
but
sphere.
Rumpus, you already
And we
know
know
what
that
the
it
moon
must be
is.
distant because otherwise you'll be able to see both sides on a
One
flat
second,
Earth.
please. 1 second. Brian, this is to you specifically, bud. Because of all of these, I'm telling you that the moon is a reflection of solidity, right? But all of those craters are one crater. This is the whole point of it, right? Everything
Gibberish.
reduces down to one crater, and we're just like in a hole of mirrors that we're seeing all of these kaleidoscopic effects, like you shine a fucking laser light against water.
And you listen.
All right, Pete,
Hang on,
but
Rumpus,
that's
the
your
alternative
own.
scenario.
That is your.
alternative
To me,
scenario.
it sounds
The
like
moon is
that's
not
your
solid.
speculation. That's your personal belief about what the moon is, right?
I'm saying that to Brian. I'm just saying that to Brian for consideration.
I gotcha.
Because he mentioned
I just
this
wanted to make
melody.
it clear
That's
that
wrong.
that is your personal belief about what the moon is that you're
Well, I'll go
describing
further.
right there.
I'll go
That's not going
further
to do
than that,
Rumpus any
Brandon,
good.
you
He's
know
never going to
that.
buy into that, right?
He can't even entertain that the moon is anything else but a solid body.
Right.
That's why
Yeah,
he
but
says
if
it
he,
doesn't
but if
work
he
with
does
planet.
what I told him to do, if he does what I told him to do and go study the moon, I mean, look
Can't
at it
work
real
then.
close. Look at
Because
all the
mine
way
isn't
around it.
scientific.
Listen
Oh
to
my
it's
God.
utterly
Rumpus
bonkers.
represents the height
We've
of
been there.
science,
We
right?
Rumpus, just go look at the
Yeah.
moon real closely and come back, and it'll only take you a second. Look at all the way around it, 360 around the whole edges of a full moon. Explain why they are so drastically different looking from one side to another. What you said wouldn't happen, what you said's not happening, is actually fucking happening, bro. That's what I
Hold on.
observed.
What
bro.
exactly is the problem again? Can you show me a diagram with your? Can you?
Just go look at the moon. Go look at the
Brian, no, I
Oh,
can't
take
guess
you
what
2
you're.
minutes.
Brian, I can't guess what's in your brain. Do you want to post a picture with an annotation saying, "Here's a problem with this moon," then I can examine it. If I'm just guessing what you're thinking, I can't do that.
Go look at
You're not.
close-up.
Yeah, no, Brian.
Okay,
You
go-
post a picture. Brian, post a picture in the chat with an
Quit being a
annotation, an
retard.
arrow,
Go look at a
with an
moon
arrow.
video, Rumpus.
All right,
with an
all right, all
arrow
right, all right.
Pointing at
Got
the
it.
problem area.
We got it.
Rumpus,
We got
I've
it.
done it with a triangle on your moon. You just dropped off a minute ago. I don't know whether you heard it.
Yes, I'm breaking up. My internet's crap at the moment. Sorry. You did
Yeah,
what?
if you look in the chat and scroll up a couple.
Right.
Yeah. Take your time, Rumpus. Gleam, in the meantime, he decided 32 miles. Is that right? Gleam, can I ask you a question before you answer that?
No, I done
Will
it at
you,
that
will
because
you
of
agree that
Eratosthenes.
when we rise up, right? When we rise up, high altitude balloon footage and footage from airplanes of eclipses at that particular height, the moon shrinks to a tiny black dot. Would you agree with that? Seems to.
Yeah,
don't
Gleam,
know,
your
I
diagram
haven't
invalidates
seen
a
it
flat
above.
Earth. What's your point? Your diagram actually invalidates a flat Earth.
Yeah, but hang on, Rumpus. Can you let me answer my question first,
Okay.
please?
He's all panicky.
I'm not panic at all.
It's okay.
It's just amusing. You've confirmed the point that I made.
Rumpus
You've
wants to
invalidated
take
flat
back
Earth. Well
into
done.
heliocentrism. We're talking about reality. Gleam, do you admit that
You
the
can't see
moon
two
shrinks
sides
to a
of it,
small
idiot.
black dot?
I
Your
don't know. I've never
diagram
seen that, Pete.
invalidates the
Shut up,
flat Earth.
Rumpus.
Never seen
I
that.
don't know. I've never seen that. I know what you're on about
Why are you
with
smiling? Why are you laughing? What do you mean? You've never
because
seen
of
that?
him. He's fucking coming in all excited, thinking that I debunked the
Well,
flat
it's just
Earth because I've
amusing. You've
drawn a
just
fucking
invalidated the flat
triangle.
Earth with your diagram.
Shut up
Don't
a
you
second,
realise that?
Rumpus.
Yes,
Let me
I'll
and
let you
Pete
go.
finish.
You have a different relationship going. Get back to my question after you
He's
finish your
hurt.
fourth
He's
page.
always hurt.
I'm
He's
just amused. I'm
perma-hurt.
not hurt at all.
Perma
Amused at
hurt.
your gibberish.
Well,
I mean,
can
the
me
fact
and
you...
me and Pete finish a conversation? Is that all right?
Well, you actually asked me a question with regard to
No,
your
you
diagram.
inserted yourself into the conversation. He was asking me something, and you went, you've just actually done. Anyway,
Yeah,
Pete,
you
no, I have not seen it. However, I have seen something which is an eclipse from above, which was one of the, it was a NASA, I think. It was a NASA plane or something, a high altitude plane that caught it. But I don't remember it being a small black dot. No,
A
sorry.
small black dot. Just type it into YouTube. Type it into YouTube. And any high altitude balloon footage from amateur hoverers, right? Amateur contributors. Hang on, Rumpus. You'll
I'm
never
not
see a fucking
speaking.
massive
I
moon.
wasn't saying anything. I was
sorry about
quiet.
that. Okay, I apologize. But you'll never see a massive moon. And where's the footage of the coincidence with NASA or anyone else sending up a high altitude balloon footage when the moon, in all its glory, whatever, in its full form, will be seen beyond the interference in the atmosphere? Where's that footage? You won't see nothing. Nothing at all.
I invite people to look at Gleam's diagram that he's posted, and it invalidates.
Because I'm just going to say it and then quickly drop off.
Hey, Glenn, you never seen the black dot for
The diagram that Gleam has posted invalidates the flat Earth using the
mic's
logic
gone
that I mentioned earlier.
Let me make a point, okay? If the sun's 93 million miles away, I know there's, even if you haven't seen it, a lot of people have seen a small black dot. Which is
Brian, your mic again.
Yeah, Mike is really bad. Anyway, Rumpus, shut up, because at the end of the day, you said you'd see the other side. You don't, you know where the 32 is? No one sees that side looking down, you idiot.
Yeah, Gleam. I just watched your video. I watched your video. They are
Gleam. Gleam. On what Rumpus
Are you
is
choked
referring
up there,
to
mate?
possibly
Are you
is
choked
you're
up?
showing a diagram where Sydney and Japan are kind of.
George, don't insert yourself into the conversation.
Yeah, stop inserting yourself, you two. You're like a bunch of insertion.
I mean, do you not realise what you've done? You have invalidated
Drawn
the
a
flat Earth
fucking triangle, Rumpus, that you
yes,
didn't
exactly.
do.
And by doing that, you have demonstrated the flat Earth model is impossible.
There is no give us the flat Earth model. Draw us the
Oh
flat
my
Earth model.
God, Rumpus,
Well,
you are
we've got
funny.
one on Squid Gleam's diagram.
So you think, yeah, Rumpus, no, let me ask you a question, Rumpus.
Diagram has
Rumpus,
a flat Earth.
Rumpus,
That's the only part of
Rumpus,
it that he's
let me
taken,
ask you
and
a
it
question.
invalidates the
Well, let me
flat
ask you
Earth
a question, and let's just prove you wrong. Okay, do you think a drawing on a piece of paper proves anything?
They all do.
If it
Are you a dickhead? Are you a fucking dickhead?
Can I answer? The drawing you've done exactly demonstrates the problem on a flat Earth. And with a drawing, you can demonstrate the geometry of reality. And you've demonstrated what the reality would be on a flat Earth, and it invalidates what we would see of the moon. It does not comport with what we see, whereas the globe model does. You by
do know
showing
that isn't
diagram,
including...
demonstrates
listen,
the flat Earth is invalid.
Rumpus, I'll prove you wrong right now. You know
They
this
are
is an
great.
orthographic view. Wait there, shut up, Georgie Porgy. Right? You see this? We're in orthographic view. Yeah?
So?
So, Japan cannot see Sydney, can it? You cannot see Sydney from Japan, even if it was a clear
Because
line of
it's on a
sight, could
spherical
you?
Earth. Yeah, that's another
No,
invalid problem. That's
no,
another
no.
problem with the flat Earth. But we're not worrying about that problem.
No,
We're
because you're
worrying about the
distracting
moon.
now. Because
Yeah,
I'm
well,
talking. This is
deflecting
lack
onto
of
another subject.
perspective.
Your
Are you
diagram
stupid?
shows
Are you
would have
stupid?
be able to see different sides
This is
of the moon
minus
from different
perspective.
points on the
Perspective
Earth,
is a
and
major
we do
component of
not
the
see
flat Earth
that.
to make it work.
Therefore, we
You're
cannot be on a
panicking.
flat Earth.
You're panicking. You
Okay,
think
I
a piece of
love it.
paper with a triangle on
Wait.
it proves something because you're so weak-minded.
Gleam, you put
Hey,
this
Rumpus.
forth. You put this forth as an option, and it doesn't make any sense.
No,
Hey,
I
Ramsey,
put that
let me,
forward to
say something
debunk
here.
him saying that you would see both sides of the moon. You don't. You see two edges, and there is spherical distortion at the edges.
Gleam, no,
There is distortion. And let me make this point before I lose it. Pete made a point about the clips from high altitude. The moon does look like a small black dot in the middle. They attribute this to glare. Okay, that's fair enough. But hold on. If it's glare from the atmosphere, if the moon is the same size, angular size as the sun, why would there be so much glare? Why would it be so much bigger? Maybe a little bit around the edges, but from high altitude, it is not what we see from the ground. It is totally different from what we observe from the ground.
Exactly.
Okay?
Exactly, and more. Here's what's more, Brian. Here's what's more. No one else on the Earth is talking about what PJ talks about. I can tell you why. The sun itself, right? If you could reduce it down to what it really is, as opposed to this interaction between these energies and the waters beyond, it would be the same size black dot as the moon.
Could it be because you're insane?
Maybe, but Aristarchus is revealed, bud. That's all.
So why do we see something different to the ballers? A question for them. Why do we see a totally different eclipse from altitude?
Hey, Brian, can I say something here, please, without you talking over me?
George. Answer that question of Brian.
Yeah, go ahead.
The diagram that Gleam is showing is basically a north-south view on the Earth to the moon. If you go 90 degrees, so you're lying on the line of latitude, so you're doing it east-west. And if
Pete, let him finish.
Pete,
Let him
put a
finish.
sock in it, Pete.
Answer Brian's question.
If you do an east-west view, the moon's going to pass one of the observers by as it's circling around the North Pole on the flat Earth, and you will see the other side of the moon eventually because it's going to pass you by and you're going to be behind it.
No,
Gleam is
George,
showing you a
listen,
north-south
you're
view.
incorrect.
Do an
You're
east-west
incorrect.
view.
It's like a maypole, and you're looking at the underside of the globe, which is on the top of the maypole. You will never see the top of the globe.
No
You will
one's
always
claiming
see
you're
an
going to see
angle
the
to it.
top. We're not talking about the top. We're talking about the
Rumpus
side,
just
the
did.
side view.
Yes, the side. Yes, and you do get liberation, is it?
Yeah.
But you would see much more on a flat
What is
Earth.
that? About 10%? And what did I calculate this
You
out
would
to
be
be?
seeing
8.3%?
100% on the flat Earth, not
No, you
10%.
wouldn't. No, you wouldn't. No,
Gosh,
you
you're-
wouldn't. No, you wouldn't, because this is
Yes, you
minus
would.
perspective.
If the moon's going past
How
the
would-
line,
what would you know?
How would you see 100%?
Westerly.
Hold on. How the hell do you think that you'd see 100%? You'd have to be right 90 degrees to it. You'd have to be.
You would be on the flat Earth. As
No,
it's
you
going
wouldn't.
around.
What the fuck are you talking
On the
about?
line of longitude or
incorrect, George.
latitude. As it goes by, you're
don't
going
know
to be
basic
seeing more and
geometry.
more of the backside.
Trig.
It's just that
It's
simple.
just trig, and you don't know it. It's funny.
Hang on.
It's hilarious.
How
Both
many
you and
qualified
Rumpus.
engineers?
Embarrassing.
Hang on, Liam. How many qualified engineers are here tonight? I'm a qualified mechanical engineer. Are you a qualified engineer, George?
Wait a minute.
Oh, Pete, you're not
George.
qualified in anything.
I'm a qualified mechanical engineer.
He is.
Rumpus-
A mechanic. He is a mech.
I
Definitely.
never said I worked in it. I'm a qualified mechanical engineer. I went through the process and I got the degree. Are you qualified, George?
Pete, do you have a degree in mechanical engineering?
Yes.
You do.
Okay. You don't speak the English?
I've heard him prove it as well. I have heard him prove
Have
it.
you?
He knows the score. He knows
Someone
the
off the bed
logic.
as well. I do. Now, I'm asking
do?
if any other qualified engineers here.
Yes, if you want to whip credentials around, I have
No,
a master's
no, I
and a
want to give you a scenario,
PhD in
George.
electrical
I want
engineering,
to give
and
you a
I have
scenario.
a
Hang on,
professional
hang on.
engineering license,
Okay,
Pete.
hang on, please.
Do
I
you
want
have
to
a
give you a
professional
scenario.
engineering license, Pete?
George, I don't value anything in regards to education, right? The child is the fucking most educated thing.
Well, that's what you just said. You have a degree. You're not valuing it
but the
then.
world values education, right? So because we've been educated, I want to
You
present
just told us you're a
George.
qualified engineer because you have a degree. I have a
Let him make
degree
his
too.
point,
I have
George.
more than
For
one
God's
degree.
sake, dude, let
Good.
Pete make his fucking point.
Right. So the point is, the only reason I mention that is because the world values education, right? So that's fair enough. So George, I'm putting you on the spot. Basic consideration, right? Which is what engineers break everything down to. Whether you're mechanical, electrical, computer engineers, you break it down to the ones and zeros. When we consider reality, and we consider our experience with reality, you missed the earlier scenario I presented, which coincided with what was being talked about. But in reality, on equinox, we're looking at the midday sun, right directly above us. But one observer, let's say me, I'm 1,000 miles north of the equator, this declination. We're on the same longitude line, so we're in line. We're on the same plane, right? You're 1,000 miles south of the equator, right? If we're trying to figure out what's going on, we have to present certain scenarios. Now, what are the possible scenarios to explain our observations with the least number of assumptions made from the very, 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 very outset?
Okay, what is the observation you're making?
We're looking at the sun. We're noting the angle to the sun. We note that along the equator, it's sort of a 0 point, right? And we also can agree, I think we can agree, that in reality we would measure equivalent angles at one particular point in time, right?
Yeah, if we're equidistant from the equator and that we're at the equinox where the sun is directly above the equator at the zenith, that's true.
Right, and it's noon our time, and we're on the same plane, we're on the same longitude line. I don't want to introduce that term.
Yeah, everybody at the equinox everybody on the same longitude line has the same local time.
Right. So we have to define.
Pete, have you got a fly in your room? Every
No,
time you
that's just
talk,
my-
there's like a.
That's my computer, man. I have it anyway.
sorry,
That's all. It's just the
Sorry,
screen.
it was
and
doing my head in. I was like,
anyway,
"Scott,
let me bring George to a
So
point
sorry.
because he is qualified, right, George? So again, we're dumbasses. We're trying to figure out what's going on. We can measure the same angle, north and south, right? So we notice this declination. So we're forced into a few categories, right? If we decide that the globe or the Earth itself is rotund beneath us, and this will account, in theory, for this angle declination. But along with that assumption, right, which is the curved Earth, we have to assume that the sun itself is far away. Would you agree with that sort of duality? You can't have one without the other. If you assume a rotund surface, then the sun that we're looking at has to be far away in order to coincide with our real experiences, me 1,000 miles north of the equator.
If we're both, if you and I are equidistant from the equator, you're north and I'm south, we're going to measure the same angle regardless of what the altitude of the sun is above the Earth.
No, we'll measure an opposing angle. It will be equal, but it'll be opposing.
What do you mean opposing?
Because we're looking at the sun at the center, right?
I don't know what you mean by opposing
above
angles.
us, so
if we
George,
measure our angles
above
with respect to the horizontal that we have,
forget about that.
We will
don't know
measure
if
the
it's
same
horizontal.
angle. What do you mean by opposing angles?
So we're looking at one another as the sun is in the center. We're 1,000 miles apart, north and south of the equator. What the fuck is wrong with you?
We're going to measure the same angle.
Yes, but there will be opposing angles. In other words,
what do you mean by opposing angles? Opposing angles generally means that if I intersect a straight line.
Okay, I get you. But
with
we're
an angle, one say is 40 degrees, the other will be 140. They sum to 180. That's opposing
40.
angles. I don't know what you're talking about.
One would be 40. One would be 40. One would be
draw a triangle from your eyes to the sun to Pete's eyes. In other words, triangle. It's opposing angles.
That's why 24 point. And that's why 23.4 in terms of the declination of the sun. This is why it's 23.4 degrees in one direction, but it's 66.6 when you measure from another direction. So there is an opposition.
Okay, if you're going to measure, all right. I get what you're saying now. If you say, are measuring with respect to the horizontal facing south, then one will be measuring an acute angle, the other will be measuring an obtuse angle.
No.
Yes.
Angle value will be the
forget it.
same because the sun is at the center, right?
Wait, Pete, let me feed off. Let me feed off of Pete here. This is very good. Okay, so if I'm 2 degrees north of the equator, and George is 2 degrees south of the equator, so we're only about 200 miles apart. Okay, and he's looking at the sun north. Just picture a triangle between my eyes, the sun, and George's eyes. Okay, now that's opposing angles, right? He's looking a little bit north, just barely. I'm looking a little bit south. Now, if we do this east and west, if he's a couple hundred miles away on a mountaintop, and he's looking toward me up at the sun, and I'm looking I'm going to be facing the same. The sun's going to be at my back if we try that east and west. So what Pete said,
hang on, Brian.
Pete, back up just a minute, just so we're on the same page. Now you realize that when I am in the northern hemisphere looking at the sun at the equinox, it's in my southern sky. When you're looking at the sun and you're in the southern hemisphere, it's in your northern sky.
Right, but hang on, George. Don't be assuming hemispheres, right? That's one aspect. We can't assume hemispheres.
Just say above and below, north and south.
That's what I said.
If I'm north, Pete, shut up a minute. If I'm north of the equator and I'm looking at the sun at noon on the equinox, I see it in the southern sky. If you're south of the equator looking at the sun at the same time, you're seeing it in the northern sky. And if we measure our angles with respect, say, to the horizontal or the horizon, or just say the horizon, not the horizontal, but the horizon that's in the southern sky, if you're in the...
We're measuring in respect to the equator, George.
South of the equator, you're going to measure the sun at an obtuse angle, greater than 90 degrees, and I'm in the northern part.
No, you're not.
Oh, God, never mind.
You guys are really belaboring this point. What's the point, Pete?
Let me clarify for him then, George.
We're getting all lost in the sauce
reality,
here, Brandon.
hang on, please. Are you telling me in reality you can't go to a point north and south of the equator 1,000 miles and point your fucking finger at the sun, look at the horizontal, and say that is a certain degree? It's at 30 degrees. I'm saying to you that we can both agree that if you go 1,000 miles south of the equator, you will get 30 degrees, the same angle, George. Now, accepting that is a standard, right? And we agree on that. Would we agree on that, first of all, George? That's why
that's what I told you, and you disagreed with me. You said they'd be opposing angles.
Yes, we're coming from the opposite sides. That's the point here. We have the same measure of angle, but it's the opposite side. But that's a different matter. We're facing one another. Anyway, the question is here, right? If we're trying to figure out reality, we have the least assumptions possible. What are the scenarios presented? Obviously, one scenario has to be that we're living on a flat, extended plane, because that's what we experience. Would you agree with that?
Yeah, if you want to assume a flat, extended plane, okay, I'll go with it.
In this scenario, and the other one then is we are living on a globular Earth of some sort, and we can extend it from that as well, and what that implies. Would you agree with that?
Yeah, we're both going to observe the same sort of thing. You can't differentiate which one we're on by making that measurement.
The other alternative, the only other alternative I can think of is a concave Earth scenario, which is possible as well. But we're not here to defend that. We're here to sort of figure out what we're limited to by the choices that we
Okay,
make.
get on with it. We're on the same page.
Okay, George. So would you agree, George, necessarily that once we decide, we're just investigating now, if we're on a contoured surface, right? Once we decide we're in that camp, then we have to, based on the angles that both can agree on in reality, which is what we can agree on. Go north and south of the equator at this particular time, we agree that we'll get a specific angle if we're equidistant from it. So with a globular Earth, a rotund Earth, we have to necessarily, logically, mathematically conclude that the star, or the sun itself, which is the star, is far away. And the only reason for the deviation is because of the rotundity of the Earth and a greater distance from the central point, which is the equator on the equinox. Would you agree with that?
I don't know what you're getting at there. I'm not following your logic here.
Let me give it the opposing camp position, because this is basic fucking research. You consider all sides. So flat Earth, right? Which
I'm
we all
having a
experience
hard time
anyway. Which you should be more
understanding what you're getting at.
Which we should be more. So hang on, George. Let me finish, please. So flat Earth scenario, because you yielded. Flat Earth scenario, right? So I have on my, actually, I get on my fucking Back to the Future skateboard or whatever, and I travel to you, to the equator, 1,000 miles, almost instantly. I'm going to notice a drastic deviation in the angle that I'm going to measure to the sun. At one point, it's going to be vertically above me. At one point, then, I'm going to be measuring your angle, which is the same angle that you'll measure. Now, if I'm on a flat plane, I have to conclude that that sun is near, which is a star. There's no other, I can't say it's far away, because if I was on a flat plane traveling to you 2,000 miles and the star was, in your terms, 200 light years away, there would be no noticeable declination in angle.
Pete, you've made this point like 5 times tonight.
Maybe
no
let
offense,
George
but...
go. This is the
Okay,
George
I get
go,
what your
Brandon.
confusion
This is
is
a
now.
qualified engineer.
I got what
Okay.
your confusion is now. Is okay. Yeah, the scenario that you just told us about on the flat Earth is correct. As you measure your angle from the south, you go across the equator, you see it direct overhead, and then you go to 1,000 miles north, and you see it at the same angle, but you're looking towards the south. Now, the point you're missing here is on the spherical Earth. We basically will see the same thing. You start out in the south, 1,000 miles away, you measure your angle, you go to the equator, it'll be direct overhead, and you go to the north, and you'll measure the same angle looking south. Exactly the same scenario. But what causes that on the spherical Earth is the fact that the light or the sun is coming in parallel to one another at both positions, and it's the curvature of the Earth that changes the angle that makes it look like.
That's all he's saying.
The sun is far away. Oh, you said the sun is far away because that's the cause.
Yes, it's far away. That's what takes. That's why with it being far away and the light rays coming in parallel, the curvature of the Earth gives you the same measurements as you
That's
do
all he's
as
saying.
if you're on a flat Earth with the sun nearby. It's the same thing. You cannot differentiate between the two with that measurement.
And off we go, Brandon.
Yeah, we know that, George.
All right. Yeah, that's the only point that Pete was trying to get you to acknowledge, is that on a flat plane, the stars and the sun has to be local. And on a spherical Earth, it necessitates it being a vast distances away. But I don't know where you were going to go after that, Pete, because, where does that get us? I mean,
I'm not in disagreement with that.
So this
really,
is right.
really,
so
hang
here
on,
we
please.
go.
Really, hang on. Brandon asked me a question. Really, you don't know where I'm going to go with that.
Thanks, Brandon.
So when George says that the stars doesn't work on a flat Earth, he will always bring in the model of the stars, like Rumpus just said earlier on, and the moon, solid bodies at fixed distances away, because they have made the sun a fixed distance away, right? A massive distance, and bring it into our flat Earth model, where he's just admitted that they cannot apply.
We know that. We know they do that.
He's forced with a contradiction and he is forced with having to admit that he hasn't considered both sides enough.
Right. It's very hard to get your mind out of the heliocentric model after being taught it for your entire life.
Yeah, but he's a thinker. He's an
but
engineer,
Pete,
Brandon. That's why I said you break these down to their basic component parts.
Hey, Pete, I've never discussed the stars over the flat Earth with you ever, or anybody ever. So don't say that I've done that. Now, if you're going to bring them in, it's the same thing that on the flat Earth, they would have to be close in. And for the heliocentric model, they're going to be far away. I don't dispute that.
So how would that work? How would the optics of that work, George? There'd have to be some other mechanism just besides... You couldn't apply sight angles to that, right? Obviously, we know in reality we can't apply declination angles and figure out the location if on a flat plane, right? Assuming we're on a flat plane, that methodology for determining where the moon, the sun, and the stars are would not work.
Yes, it cannot.
So we
because you're dealing with
right.
solid body trigonometry in the other scenario.
Right. So we know that doesn't work. Now that's where some people make the leap that falsifies a flat plane. But you're assuming that methodology is valid, that it should work in reality. How can you think of a
missing here, Brandon?
Yeah.
I was going to just get to my question. I was going to get to my question.
We know there are solid objects. We know there are solid objects. We can bounce radio signals off from them. And
all right. Look, we're going to ignore that for now.
I'm
going to ask my question. I'm going to ask my question. I'm going to ask my question. I'm going to ask my question. By what mechanism do you know? By what mechanism this relationship between distance and declination would work on a flat plane? How does that work?
Excellent. Can I answer this without Pete interrupting?
Done. Off you go, George.
Now, let's just take the sun, for example, in the scenario that Pete gave us. We're 1,000 miles above the equator, 1,000 miles below the equator. We measure that angle. We can do that along the same line of latitude, say at 500 miles each way, 2,000 miles, 5,000 miles each way. And if we do that and we measure those angles and then we do solve the triangle, the right triangle, remember the sun's going to be directly above the equator, so you can form a right triangle. And if you plot out those angles, you will find that the sun will not be in the same position if you do this on a flat earth. The sun will have to be at different heights for each of the observers that's measuring these angles.
That's what I just went through. That's what I just acknowledged, that does not work in reality. And I'm asking you, we're on a flat plane, so how does it work? Because obviously you can't apply that straight trigonometry method to site angles on this flat earth that we're on in reality and have it work. So how does it work? How optically does it work, George?
I just told you on the flat plane, the flat earth, it won't work, but on the globe earth, it works.
He's screwed. No one can handle it.
It does work on the globe earth. You can show it very easily on the globe earth that at different distances from above and below the equator, if you measure these angles to the sun at noonday during the equinox, they all point to the same position in the sky.
Yeah, I get you. I'm asking you to be on the flat earth with us and figure out how the optics of the celestial objects work, since that methodology doesn't work on our flat earth.
I don't get your question. Wait, what do you mean? How the optics work?
No, Brandon, let me clarify this for him perfectly.
Sure.
George, so in the flat earth scenario, which is what Brandon, we're looking for a more complete picture. You've already admitted and conceded that the stars must be much nearer. So if the sun, which is a star, is much nearer, it cannot be the same size then, George. Isn't that correct?
What do you mean cannot be the same size?
As given in the opposing scenario, the heliocentric scenario, it cannot be the same size because it's much nearer. It cannot be the same size. It cannot be 1,000,000 miles across.
Oh yeah, agreed with that.
Right.
Sure.
So will you also agree that there's a possibility that it cannot be of the same kind, of the same constituency? So in other words, you present us with a solid, fundamentally a solid body core burning in space. It cannot be that way in
Well, of course not. It couldn't. If you had a nuclear furnace like the sun, 1,000 miles above the Earth, it would cook us. Sure.
You have so many concessions tonight. So, what are the alternative possibilities? All we're asking you is possibilities. You already accepted the rest of the limitations. In a flat Earth scenario, I can give you my answer, George. They're all reflections. But what are the possibilities that you will entertain as associated, needs must, by your concessions, associated with a flat and stationary Earth surface? What are the other possibilities for the stars and starlights? Which is everything in the universe outside of the moon, ultimately, because remember, the planets are wandering stars as well. Did anyone say ours star? What do you think, George? What do you think, George? What do you think, George? What are the other possibilities?
For above the flat Earth and being only several thousand miles away, I can't think of any possibilities other than points of light, as you're saying, but I don't know how you would have them up there in these constellations.
What about if your empty space, George, was replaced by its opposite? It's maybe natural opposite. Heavy waters, for instance. We know that the Earth is covered with 70% saline waters.
Sure, I know where you're headed with this, Pete. And
right.
That's your flat Earth model. That you have a
No,
dome.
it's not my
and you have
model. I'm
these
asking
little
you to
twinkling
consider
lights attached to the
possibilities.
dome and stuff to account for
You're
it.
the
This
engineer,
dome
George. You're
rotates
trying to
or
work out
whatever.
truth.
Okay, I mean that's your model. Fine, go with
Why
it.
can't you go along with that possibility? If you haven't thought of one yourself, maybe you can consider that and put that in the flat Earth camp.
It's
and say,
contradicted
well,
by
Because
reality.
it doesn't make sense. We've gone way
Make it
beyond
work. You haven't even
7,000
considered it.
miles with spacecraft and satellites and rockets. It's bullshit.
I think this is a losing battle,
Everything you
Pete.
said is bullshit.
All I'm asking from you, George, is we all know that the straight trigonometry methodology doesn't work in reality. So if we're on a flat plane, it has to work in some other way. I think that it's not far-fetched at all that there is another way that it works. And I'm just trying to get you to think of how it would work.
The other thing that I want to say, just real quick, just let me jump in real quick and say that there are other numerous issues of physics that are a part of this discussion. So this isn't like the one thing that's going to crucify the model, right? Simply because we might not be able to explain the difference of angles to the sun in 3 different geographical locations. That doesn't take away from other instances of physical evidence on Earth that we would use to argue for a stationary plane. Okay?
Of course. Yeah.
Well, actually, that's wrong. I mean, sure,
Okay.
we can invoke
No,
magic
that's
and
not- no,
stuff
that's
that we
not
don't
wrong.
know about. Sure, go ahead, do
not
that.
wrong.
Wait a minute,
But
magic?
95% of the globe model, dark matter, dark energy.
We
Yeah,
have
we can do that.
instrumentation. We have ways to measuring these things. We've distance, radar distance.
You got a lot of balls coming here as a heliocentrist and talking to us about magic.
If you want to invoke magic or whatever, run with it.
You got a lot of balls talking about magic, George. In your model, time travel's possible. The length of objects changes depending on how fast they're going. This thing called
67% of
space-time
it.
bends and causes
dark
objects
energy.
to attract to each other for whatever reason. There's
We're talking. None of that has to do with the heliocentric model and the fact that the
Really?
Earth is spherical.
dark energy, dark
Special
matter,
relativity, dark energy, all of that. That's not part of the
the plane of the
heliocentric model.
ecliptic.
Hang on, Brandon.
I know,
The Big Bang.
but it's been found to be.
Earth is a heliocentric model. The heliocentric
who's the
model
father?
is
George,
just
who's the
the
father of
sun, the
heliocentric?
Earth, and the planets. That's all
I'm
the
just referring to the current
model is.
cosmological model that we refer to as the heliocentric model. I understand the base idea
you're
is
wrong.
that
You
everything
should be
revolves
referring
around
to
the sun.
standard model as a heliocentric model. The standard model of the universe is something entirely
No,
different.
just talk
than
about a
the
total
heliocentric
model. No need to isolate it. Just talk about a total model.
I don't know what
Come
you're fucking talking to George for.
This is an important question. This is an important question, please, to Brandon and George. Do you know who the father historically credited of heliocentrism is? Do you know who it is? You said it was going to mention once tonight, Brandon. You maybe have to mention it again.
It's George LeMaitre, a Catholic priest.
Aristarchus Samus. It is.
I'm sorry. Somebody else take over. I can't.
Anyway,
handle Pete
George,
anymore.
do you not think that?
Pete's bullshit.
Let me ask you a serious question, George. Let me ask you a serious question, though. Do you not think that the current standard model, if you took a step back from it and looked at it and saw it with fresh eyes, let's just pretend you were just born, right? He left, but anyway, I'll finish. And you took a step back and someone told you, we're on a spinning ball that is floating, for lack of a better term, tethered to a giant gas ball that is traveling through an ever-expanding explosion of matter and with nothingness in between. And there's a magical, I'm going to use the word magical, there's a magical force that causes all this to work synchronously over time without losing any of its energy. Does that not sound like magic?
Sounds wonderful, yeah. But it's
It
kind of
sounds
like
like
when you
magic.
say the magical force. You say a magical force of gravity. I mean, you're right. That's a magical force, and so is dark energy, the thing that expands us outward. That's a magical force. I mean, that's all true.
Yeah,
I
so-
agree. It does sound magical, though. Yeah.
Yeah, so why can't we have magic?
It's not even magic though, Brandon. It's
No,
a
man,
bend
Brandon,
of
we don't
light.
believe in the magic.
That's all you need, a bend of light. If you look at Walter Bislin's model, he says, "Oh, I can't explain all this bendy light."
Brandon,
Obviously, didn't
Brandon,
read
the
any of
point you
Einstein's
miss
work.
in any model, it has to be self-consistent. The heliocentric model is very self-consistent. There are no contradictions in the predictions, whereas with your flat Earth, you come upon contradiction upon contradiction. You come up with an explanation that explains phenomena A, and then you get on to phenomena B, and in explaining phenomena B, it breaks your
Hold on, Brian.
explanation for phenomena A. It's not
Hey,
self-consistent.
George. Okay, look, George, just real quick. Just like in your world, science doesn't prove anything. In our world, our science doesn't have to create an answer for something that we cannot test or validate. So simply because we don't take leaps into your camp and try to answer something that we cannot test or validate, that puts us on the same playing field in terms of how
we can test and validate everything. We've tested and validated the distances to the stars. We tested and validated the tilt of the Earth, the spin of the Earth. We know we can make predictions.
Okay, listen very carefully. Just real quick. Hold on, Gleam, sorry, or whoever that was. Just real quick. Okay, so George, let's just stay with observations over water where there is a refractive phenomenon happening. Okay, I don't care what kind of refractive phenomenon it is, it just is. Let's take it for granted that someone from your side takes a picture and crunches all of the numbers and says, this proves that the curvature of the Earth over water is blocking this distant ship. And that means that the horizon is X amount of miles away. All right, so he's got photographic data. He's got distances where he knows where the ship was and knows what his height was. He also knows the optical data for the corridor through which he's looking. So he crunches all of the numbers and he gets the mathematical equation for where the horizon is. Do you know what step he has to do next in order to validate everything?
Why are you gish galloping around? We were on the heliocentric model.
Simple,
now you want to bring in your favorite topic, refraction.
Let's answer the question.
That has nothing to do with the heliocentric model we were talking about. I'm not going to gish gallop around with you, Travis, all over the map. You either stay focused or just stop it.
Listen, George,
listen. My conversation with George, Dad.
Come on, Pete.
Are you serious? You heard the answer he gave.
Let Travis continue this if George wants to answer.
Okay, just real quick. Okay, just real quick. George, you said that you have answers for everything, right? You said that you've proven everything. I'm simply choosing one thing.
I never said that. You're full of shit.
You just said that your model. You just said your model has an answer for everything. You can test everything.
For the observations in the heavens of the planets. That's what we were talking about.
The Earth is very flat.
Can't be falsified, George, right?
Oh, God.
Can't be falsified, right, George? You haven't been able to falsify.
We get it, guys. We get it, George. You guys don't want to deal with
Travis, let me ask George just to finish our conversation then, George. Hang on. To finish our conversation then, George. So, the two tenets, right, of the scientific, philosophical, inquiring mind. One is that the truth is worth more than the man, right? More than the man's life. Now, the second one is to look at everything as if you're looking at it for the first time. You present the finished picture, and every single real collation of data will be molded around that, that finished picture, because here's the point here, there's an intent to deceive. And if we don't acknowledge an intent to deceive, then we're lost from the very outset.
George, I want to make a point about what you said, that their globe model doesn't lead to any contradictions. Well, let's just put that aside for a minute. It does lead to absurdities, such as physical objects changing their size, their physical size, based solely on how fast they're going, and time travel. Those are ridiculous, and there's contradictions in there. With time dilation, there are obvious contradictions that happen if you play it out.
No, you're wrong. Objects
No, I'm
do
not.
not change physical size when they go faster. It's a
So you're saying it's optical. I forgot that you took that position.
See, again, you don't see, you're trying to bring stuff in you don't understand. You've talked to people that don't understand special relativity. Objects do not change size physically. They change size according to a reference frame and from your frame of reference because of the way we measure simultaneity. The way we measure simultaneous events, it appears that the object changes size,
wizard, dude.
but it
You're a
does
fucking
not
wizard.
change physical
That all
size.
comes with a
Hold on,
with
guys.
assumption.
I think his own side's going to disagree with him. Go ahead, George. Finish up. Kosho in here? I guess you're finished.
Yeah, I'm in here. I was eating some chicken, but
I think this is contrary to what you've said in the past, Kosho, and many other people. George is saying that these effects are optical.
I never disagree with that.
Effects are optical. That's not what I said, Brandon. See, you missed
Say it again then. Say it again then.
Optical effect. Jesus.
Then explain it. Explain your position on time dilation and length contraction.
Yeah, mention the Lorentz contraption.
It has to do with how we measure simultaneous events. The fact that there's a finite speed of light, there is no such thing as having a reference frame in which everything is simultaneous. It takes a finite time for light to reach our eye. So when an event occurs in a reference frame that's traveling fast with respect to my reference frame or your reference frame, then the event that seems simultaneous in the fast-moving reference frame is not simultaneous in ours. So we conclude when we make these measurements that the lengths are different. It's because
What are the assumptions?
Hold on, Pete.
I can't talk with Heath.
Guys, you got come on. I asked him to explain his position, and let me follow up on that, because here I'll give you one of the absurdities that leads to, and maybe you can explain it to me. So it sounds like you're saying it's just about the reference frame and the light you see in your reference frame from things happening, I don't know, in the world, I guess, around you. So let's say I'm watching a spaceship and it takes off from Earth, and I watch it with a telescope and it goes, what is it, faster than the speed of light, right? It nears the speed of light, right?
Than the speed of light. Can't go faster than the speed of light.
What about light speed?
Okay, so it
goes light
goes.
speed either. It always has to be slower.
Wait a minute.
Are you telling me that time's not going to slow down? The twin paradox isn't going to take place? That twin's not going to get back and be younger than his twin that's left back on Earth?
I didn't say that. You said, you gave me a scenario. You're just saying you're going faster than the speed of light. The spaceship's going faster. I said it can't do that.
Okay, it's nearing the speed of light. Excuse me. It's nearing the speed of light. The twin paradox. The one twin goes on the ship, goes off, comes back, and he's younger than the one that's left back on Earth. That is not optical.
Okay. Now what's your
That
point?
has nothing to do with the light traveling to a one position from different positions. That is one person being old and one person being young due to how fast the one traveled.
His point was that's absurd.
No, it's not absurd in general relativity.
No, there's more to it, though,
Pete, will you shut up? You have gone out of the realm of special relativity when you go out and you return, because you have to deaccelerate and accelerate. Now you're in the realm of general relativity, and special relativity explains it differently.
But Einstein solved the universe from his armchair, George, and you
that's what I brought up in the.
Please, hang on, okay.
That's what I brought up in the first place was time dilation and length contraction, and you said you started giving me an optical explanation for these about how fast light travels.
Not give you an optical explanation. See,
I said the length of objects changes depending on how fast it goes.
See, you really need to drop this because you don't.
No, I don't need to drop it. See, I'm getting a contradiction just from you, from talking to you for the last 10 minutes.
You brought up time dilation. I did not. You're the one that brought it up, and you're misconstruing what it means because you don't understand the difference between special relativity and general relativity.
Let me ask you a question real quick, George. When the line between general relativity and special relativity gets crossed, do you hear this sound?
That's the ether band sort of declination, Travis.
So George, instead of giving us
Travis, I'm not going to answer your question. You're just too damn stupid to even be in this discussion.
Okay, George.
The only difference is something's accelerating.
You gave us
the rubber band. That's the ether band, just tingling as you pass the no.
Travis, I've been down this road with you too many times to know that all you do is try to disrupt. You try to twist things. You have no understanding of any of these things. The difference between special relativity and general relativity is the fact that in special relativity, accelerations are not allowed. You're only allowed to go at a set speed, constant speed, which we call inertial reference frames, frames that are moving at a constant velocity in a straight line direction. No turns, no accelerations, no decelerations are allowed.
Great, good. I appreciate your comprehensive knowledge of this matter. I'm simply asking you now, show us what you're talking about with a real example. Show us step by step. Don't tell us the story. Say, this is this, that is that. Now this is happening, now that is happening, right? Can you show it to us?
I told you it's an issue of simultaneous events and how we view simultaneous events and
so you can view them.
A simultaneous event that occurs in one reference frame that is moving at a constant velocity
you're telling
with respect to another reference frame is different.
Again,
you might view it. You're in a rocket ship moving near the speed of light relative to me, and you do something.
George,
is
this a real event that you're talking about right now?
And you break a vase. From the time you swing that hammer to when the base is broken, what you'll find is a short time. You consider that to be basically a simultaneous event. In my reference frame, I can see it much differently than that. I can see.
I get it.
Don't be interrupting.
Hold on. I get it. Wait. This is just like the Pevensey children. The Pevensey children are looking for Lucy, and she steps into the wardrobe, and from her perspective, she spends so much time with Thomas.
Come on, Travis.
Right? That's what he's talking about.
Hang on, please.
Oh yeah, hold on. Let me bring this back to where I started with this. Hold on, Pete. Let me bring this back to where we started this conversation about time dilation and length contraction. Was I said that your model, the standard model, leads to absurdities such as the lengths of objects changing, physical objects changing depending on how fast they go, and time travel.
Say that.
I said that. I didn't say anything about general or special relativity. I said these two effects, which are claimed by the standard model, are absurd, and you went off into some fucking esoteric knowledge about general versus special and some semantic argument about reference frames. Do these two things happen or not, George?
I told you before. Will you let me speak without others interrupting and without muting me? Again.
Yeah, let him speak.
Again, physically, in your reference frame, when you are moving in this spaceship, you do not physically change size. Your length doesn't change. It is not a physical effect. It's an effect of measurement. How when I'm in the laboratory, or when you're in the laboratory and I'm in the spaceship moving relative to the laboratory, the measurements that I make in the laboratory are different than the measurements you make in that spaceship. And this has to do with simultaneity and the fact that the speed of light moves at a fixed finite velocity, not instantaneously, but a
Who
finite
established that,
velocity.
George?
So what I'm measuring is a different length than what you're measuring. It's not the fact that you or that this object is physically changing size or getting squished or anything like that. Mass doesn't change, the physical size doesn't change. Just how I measure it changes. This is what special relativity is all about. Why don't you just drop
So you're
the special
talking about
relativity?
optics,
You can't
George.
understand this. You don't have
Length
the
contraction.
mathematical tools
So
and
you're
all
talking
you
about
do
an
is try to
optical effect. Hold on.
qualitatively understand this,
George, you got to take a break. Take a breath. Take a breath. You're talking about a optical effect. Now, what about time dilation?
No, I did not say an optical effect.
You did.
Yes, you are. You're saying that the light coming from the object is measured as a different size than the physical object. The object isn't changing size. You're just measuring it because of the way the light is getting to the viewer. That's essentially what you said.
You're winning, Brandon, when he starts slamming his hand on his chest.
Hey, how close am I on that impersonation? Pretty
that
close.
was good. Yeah, that was good.
All you
Listen,
gotta do is
my whole
define
issue
what a reference
again.
frame is.
Go ahead, Paul. Go
Have
ahead.
him define what have him define what a reference frame is. Because as soon
Well,
as
I don't want him to slip away from this.
Brandon
I
wins.
don't want him to hold on, Paul. I don't want him to slip away from this because he's saying it's optical, then he's saying it's not optical. I want you to talk about time dilation, George. Is time dilation just about the reference frame and the light coming to the viewer, or does that actually happen? Does time actually go slower for one observer than the other? Is the twin paradox an actual thing that would take place?
Time.
Doesn't know what you're talking about.
Oh, God. Let's just stay focused first on one point. Do you want to do the length contraction or the time dilation, or do you want to mix everything up here?
Hold on. Just if you do that, listen, if you do that, do something specific. Not put yourself in a spaceship, because you're not in a fucking spaceship, George. So do something real on Earth.
Wait, I just want him to tell me. I want him to just answer the question. Hold on.
Frames of reference.
This is way too complicated for flat earthers. I mean, they can't even.
Guys, shut the fuck up, Billy. I just want you to answer the question, George. Is the twin paradox something that would take place in your model or not? Would the person be younger than his twin when he got back because he went near the speed of light? Yes or no?
Yes, because of general relativity, not the special relativity you are trying to talk about.
So that is a thing then. Time travel is a thing in your model.
It's not part of the heliocentric model. I don't know what you're talking about. See, you keep doing these model things.
Yes, it is.
Putting all this under heliocentric model.
You're
This has
wrong.
nothing
It was
to do with
Einstein who
shape
proved
of
the
the Earth.
heliocentric model, wasn't it? With
Just
the Mercury
black hole.
precession.
Yeah, again.
The horizon of a black hole can allow you to go through time in their model.
Brandon didn't say heliocentric model right now. He just said model.
I said standard model. Yeah, I've been careful to say that the last few times because you corrected me.
Right.
Okay, yeah.
Try to them and say, okay, different aging is the time. That's your thing. And Brandon's point is like you could basically, I guess, keep track of it, keep your eye on it the whole time, and witness it happening right in front of your eye, basically.
Well, hang on, please. This is
Well, actually, it does. Time dilation can be witnessed on the Earth by looking at mu mesons.
Hang on,
They come in from outer space, and in the laboratory, when we look at the lifetime of a mu meson, it has a certain lifetime. It's very short. And given that measurement of mu mesons in the laboratory, we know that they should never arrive on the Earth from the outer atmosphere. Yet they do, because their time has slowed down.
This is where I'm best. Probably
I've heard this story before, and all I asked you is if it's a thing. If time dilation is a thing, if the twin paradox is a thing, you said yes. I made my point. We can move on.
Right.
Go ahead.
George, this is where. Hang on, please. Can I say something? I was muted there for a bit, which is okay as well. It's a passionate sort of thing. But this is where probably best to challenge George in a certain sense. All right, if someone's trying to speak, off you go now.
I'll challenge George.
Okay.
Tell him to
Well,
look
George,
up or spaceship paradox.
this is
Get
where we're
two.
getting back to
Oh,
basics.
are you
then,
into
right?
it?
So hang on, please. George talked about all of these clarifications. Where did they come from, George? Did it come from the mind of a man called Einstein, who figured out pretty much the universe from his brain, from a blackboard screen? Is that true or not? Is this just historical fact?
Yeah, Einstein was the first to really formulate it
Right.
into a form that people to
He didn't
present
do
it as
any
a paper.
experiments.
Yeah.
Okay, he didn't do any experiments himself, right? So if he was wrong, he would have just cast aside in history as another cuckoo. But within his brain, he did not move from his armchair. He figured out the universe, and every
Yeah, he
measurement
did. That's what's pretty
every
amazing.
measurement. Hang on, George. Every
Okay.
measurement that mankind is capable of measuring, every sort of challenge that mankind is capable of offering, Einstein's theory of special general relativity has always been proven to be the case, right?
Yeah,
So,
we've taken predictions made by Einstein from his general and
right.
special relativity and actually tested it and found to, in every case, Einstein to be correct. In fact, special relativity is one of the most tested theories in all of physics.
Not in the
Right.
Doppler flyby, by the way. It
Right, but the
contradicts that.
point is here, he figured it out from his brain, right? He's thinking
Yes, he
power.
did. Yeah.
Imagine
That's
you,
what was so
imagine you,
wonderful
George. Hang
about
on, please.
Let's
This is my
let
point.
Gleam.
I'll
Let's
finish
let
here.
Gleam have a shot. Go ahead,
I'll
Gleam.
finish here.
Yeah, sorry. Either way, I don't know. Me and George has got a history of Lorentz, but just to make it easier, Lorentz basically got both of the theories of time dilation and length contraction from electrons, how electrons act, and he freely admits that length contraction, the contraction of something physically, is taken from an electron. And it gets nearer to the speed of light, it will measure to be smaller. Exactly what he said.
Electrons have no physical size as far
I
as we
know
Gleam.
now.
We
Now
can
we
measure
do,
down
you
to 10 to the
idiot.
minus
We're
50
talking
meters,
Lorentz
and
in
an electron is smaller
1900s.
than that.
We're talking Lorentz in 1900s, before any of the nuclear phase. Come on, George, calm down. We know that I corrected you on Lorentz's transformations because you said they had nothing at all to do with ether when they come from Lorentz's ether theory.
Gleam, stop a minute. Number one, electrons, as far as we know, don't have any real physical size. They could
Now.
just be point charges. We have
Yes,
never been
now.
able to Gleam, quit interrupting me. We have never been able to measure the physical dimensions of an electron. We've gone down as far as 10 to the minus 15 meters, and we still have not been able to detect any
Irrelevant
physical size
stuff.
of the electron.
Electrons are the ether.
Irrelevant stuff, because that is not my
No,
argument.
it's not irrelevant. That's what
It
you
is.
just said.
It's
Electrons
not,
were used
because no, it
determining
was.
physical time dilation or
It
whatever.
was under the mathematics.
Length contraction. Yes, you did. You just said it a little
Did
earlier.
Lorentz not figure out the electric component of electromagnetism? And did he not get length contraction from Oliver Heaviside, who figured out the magnetic component?
So what's this all leading to?
It's all saying that special relativity and the whole Lorentz transforms are embedded in electromagnetism. And that is why you need to look into Bell's spaceship paradox. Because you get, oh God, not that one that destroys my argument. The one where you get two spaceships, you put a tether between the two, and in all calculations, that tether should break when it shouldn't.
What?
Do you know what Bell? Please tell me you don't know what. Oh, my
I know.
God.
I'm talking about
What is
where
Bell's
you're talking
spaceship
about
paradox?
breaks. What breaks?
Okay. The tether. I just said the tether between the two. Okay,
Tether
George.
between the
George,
two.
let me ask you this
Tether.
one question. What is Bell's spaceship paradox? Go.
Gleam.
No, you are.
You know
where
about
your
length
head is with
contraction.
this. What
It's
are you trying to tell
100%
me?
He
Are
asked
trying
you
to-
a
are you trying to
question,
tell-
George.
I'm trying to understand where
He
this is
asked
in
you a
relationship. Oh,
question.
shut up, Travis. I'm trying to understand where you're going with respect to special relativity. That's what we were talking about. Now, special relativity can be described by the Lorentz contraction equations. So, all right, the Lorentz Fitzgerald equations. Yes, Einstein derived them also independently. So
no, he did not independently, you
the
silly
deal?
fool. You
What's the
silly
deal?
fool. Do not try and say independently when Lorentz was Einstein's professor in the University of Leiden. Where the hell do you get he done it independently? He got them from
what I mean is
Lorentz.
Einstein derived it by assuming that the speed of light is constant.
He
Lorentz
got
didn't know
that
that.
from
Lorentz did not make
Lorentz.
that
It's in the
assumption.
history of
He just fiddled around with equations and got things
rubbish.
to work.
It was
whereas
Poincaré.
Einstein
It
put
was
a real
Poincaré.
basis to it by
You
saying,
do not know
look,
the
I
history,
only need
George.
to make two assumptions that all physics is the same in all inertial
Incorrect.
reference frames.
Incorrect. It was Poincaré who fixed the
and
speed of light and sorted out
finite.
Lorentz. You're
That's all he
talking
had to
rubbish.
do, and he could come up with the Lorentz
You're talking rubbish.
equation. So
It was already
you're
fixed. It
galloping
was
around,
Lorentz.
You're taking
Look,
us
you can
nowhere down
listen.
that path that you've
George,
got this bone to pick. You've got
okay.
this thorn up your ass because of my electric universe.
Right, George, either way, listen and listen close. Yeah? Babbling on completely. Lorentz transformations are embedded in ether. If anybody wants to know, I'm just going to cite mainstream science here. Go to PBS Spacetime, look up how ether led to special relativity. And it will tell you there that Mr. Lorentz was the one that first said that there should be a fixed speed of light. Why are you interrupting me, you idiot? Then, in his mathematics, he formulated and he said, I'm going to ad hocly introduce length contraction. Now, he got his maths wrong in his paper, and Poincaré took it over. And they were both etherites. Both of them believed in the ether, and they together formulated the Lorentz transformations we know today. And they are the ones that Einstein said, thanks, professor, my professor, you've done the maths. I'll grab those maths and I'll go and take them to Minkowski. And let's see what we can do. And let's embed that maths in the space-time or framework that Minkowski done. It's seriously, I don't know why he has to act all, yeah, I know about it. I will say now, I do not know about it. Anyone claiming to know about this in and out, all I know about is the history, because I've just read the history and I've read a lot about it.
Are we going to be here for hours, Gleam, or are you going to finally come
Hey, you've been
to an
talking
end?
for an hour. Come on, George. You've been talking for an hour and I've kept quiet.
No, I haven't been talking constantly in a monologue like.
You
Right,
and
go
Pete
ahead.
have been
Who-
talking back and through.
Go
What
ahead,
did you say was
respond, though.
Einstein's professor?
Lorentz, Hendrik Lorentz. Hendrik Lorentz was Einstein's professor. You know that picture where it shows Einstein and all the big famous top scientists? It's Einstein and Lorentz
Gleam,
right
come
in
to
the
an
middle.
end, Jesus Christ.
No, I'm speaking about a different topic.
No, you're just.
He's just asked me a question. Why are you getting angry, George?
I think he
That's
wanted
a
to
sign
respond.
of a wrong man. That's the sign of a wrong man. But you know that
You've
picture
done this 1,000 times before, Gleam, you and George. You know it.
all the time. But anyway, Lorentz, yeah, is the old guy next to Albert Einstein in that big picture. Now, to top it off, and a real big massive clue about this, is that the guy behind them both is one of my favourite scientists, Sir Paul Dirac, or Mr. Paul Dirac.
Jesus, Gleam, come on, man.
Why? What do you need to say, George? Because you're just shouting. Are you
Come
really
afterwards.
impatient? I'll stop now. I'll go on mute another hour.
Nick, didn't Paul Dirac come after Albert Einstein?
He debunked him.
Oh, he debunked him. Oh well, should we
Well,
know that? fucking
mechanic-
Einstein? But
not-
hang on, Gleam. This is the point I was trying to raise with George. Easy
Dirac
to
did
debunk
not
George if he
debunk
answered honestly.
Einstein.
But
No
hang on,
way.
please.
He did.
Okay, but before you
No
hang on,
way.
please. This is to Gleam especially. Once we understand that the spinning ball earth and everything associated with is nonsense, is it nonsense for deceptive reasons, or is there greater clues encoded? Is the lie built on the truth? So what does it tell us about the actual truth? I think this is the ultimate quest. Off we go.
I don't know. But that fly,
it's
I'm
hard
going to
to
leave
connect
George.
with.
That fly
I'm going to
is
leave George to it. Sorry.
Can I read
George,
something?
I'm gonna-
Oh yeah, George didn't get a chance to respond. George, go ahead.
All I'm going to say, I'm not going to take up much time here, is Gleam is just galloping around trying to impress people with
Oh my
his
God.
use of jargon. He's never gotten over the fact that I've destroyed him in Ranty's hangout on his galactic rotation paper, and I debunked his electric
Just
universe.
galloping,
And
George.
he's
You're
never gotten
stroking
over
yourself.
this. He just has a thorn
Stop
up his
stroking
ass, and
yourself.
he just won't let it go. Just move
All
on
right.
for once.
We've heard this
so
story
that we
before,
can move
George.
forward.
All right. Let me read this, and you tell me if this sounds like a coherency here. In physics, the twin paradox is a thought experiment in special relativity involving identical twins, one of whom makes a journey into space in a high-speed rocket and returns home to find that the twin who remained on Earth has aged more. This result appears puzzling because each twin sees the other twin as moving, and so as a consequence of an incorrect and naive application of time dilation and the principle of relativity, each should paradoxically find the other to have aged less. However, this scenario can be resolved within the standard framework. Here's where it gets really special. Of special relativity, the traveling twin's trajectory involves two different inertial frames, one for the outbound journey and one for the inbound journey. Another way of looking at it is by realizing that the traveling twin is undergoing acceleration, which makes him a non-inertial observer. In both views, there's no symmetry between the space-time paths of the twins. Therefore, the twin paradox is not a paradox in the sense of a logical contradiction. You tell me that is not religious bullshit.
That's what I told you earlier. You're conflating special relativity with general relativity. When you allow accelerations, you no longer are in the realm of special relativity.
Hang on, George.
In special
Hang on,
relativity, it does appear that the two twins are both aging or slowing down with respect to the other one. That's what happens in special relativity. And you can never resolve it in special relativity because you always have to be traveling at a constant speed with respect to one another with no accelerations. Now, if you want to compare the twins, you have to go into general relativity, where you now are allowing the spaceship to slow down and turn around and accelerate back to get back to the other twin. That's no longer special relativity. That's where the symmetry is broken.
But George,
I
the
think
twin,
Brennan's
the other
point,
twin, hang on, please.
Brennan's
Hang
point
on.
is not about
Hang on, please.
which
Hang on.
relativity it is.
Hang on, please. George, the twin, the other twin that the twin returns to will not be in the same position because he's on a spinning ball Earth, right? Spinning through the universe.
Okay, dude.
according to rules.
Yeah.
Let's bring it back. Very much the point, man.
No experiment can detect if you're not accelerating, no experiment could detect which thing is moving. That's the fucking problem right there, guys. Is that?
No, but that's not. But listen, that's not even the point, though. I think Brennan's just pointing out that it's the strange thing happens. He's not claiming which relativity it is. He's saying this strange thing is claimed in either one of those.
Yeah, but hang on, please. That's
Yeah, no, Kosho's right. Hold on. Kosho's right. I don't care which relativity it's in. I'm saying that it is a fucking crazy thing to go around saying.
Okay.
That's what I'm saying.
Brandon, you might think it's crazy, but we've demonstrated it.
No, you haven't.
George.
It's been demonstrated.
You have not demonstrated that time goes slower
GPS.
depending on how fast you go. You have not demonstrated that. You've demonstrated that there is an effect that happens to what is it called? Those particles. Anyway, that the clocks change. Something impacts the clock. You have not proven that you can fucking time travel.
Yes, we've done it with atomic clocks. It's been done several times. They've taken two atomic clocks, synchronized them on Earth, put one on a rocket, or not a rocket, but a jet airliner, and ran it around the Earth, and came back and compared the clocks. And
I know
the times were different.
I just acknowledged that you've done it with clocks. So you took one clock up in a plane, flew around, then compared it to the other clock that were synchronized before. And the clock that flew around showed us an earlier time than the one on the ground. Big deal. So the speed impacts the clock. It doesn't change fucking time. You don't time travel. You haven't proven that. You haven't proved that the twin would be younger when he got back.
Timing on the clock, the atomic clock. It's an atomic process.
It doesn't equal time travel.
Yes, it is. It's a nuclear process. Nuclear clocks aren't affected by humidity, temperature, things like that. All that could have changed was the reference frame because of the speed of the airliner. That's what's demonstrated that time dilation is a very real thing.
No, George.
You know, it helps demystify
you can
it.
say no, but everybody else. Oh,
You're taking one
helps.
thing. This is what you're doing. You're like the Scientologists when they use that little thing on their hands that picks up the electricity in your body on your skin, and then they say that is detecting past memories from earlier in your life or in previous lives, and that you need to purge those in order to feel better.
Okay. Well,
So that's what they say. They take this one little thing in science, which is that your skin has electricity and it changes depending on what you're talking about, and they start talking about past lives. That's what you're doing here with this twin paradox and time travel.
Objection. Now, what are the mechanisms that you are claiming that accounts for the time change?
Speed, evidently. You're telling me that's the only difference.
That's what time dilation is
It
all about.
affects the clock. It doesn't mean time itself changed.
He's ignored the paradox. Ignoring the paradox.
Can I say something very quickly so that I think this can be demystified because this all came about by the simple, that's why I keep posting that GIF that I made, because if you agree with the simple fact that it's light that is a constant, the speed from all reference frames, and so now all you have to do is describe two different reference frames that are or two different inertial reference frames that are observing the same experience, the same light experience. They're both going to be perceiving the speed of light to be the same. And so just like in the picture in the GIF I posted, if from one observer one's moving left to right, then in order for the speed of light to stay consistent, the time actually has to be different from that observer compared to the observer who's moving with that light.
Well, let me tell you something. That's the absurdity and contradiction that I'm talking about, that your model is eventually leads to. And you have chosen to believe that time travel happens based on this concept here and the mathematics that is in the standard model. What I'm saying is you don't have any evidence that you can time travel. That's a religious belief.
Fine, Brandon. Let's move on. I mean, what's the point? All right, you don't want to believe in special relativity or accept the consequences of special relativity. I do. Okay, we have a Mexican standoff here. All right, let's forget it and move on.
Well, I'm fine with that.
Demystifying part of it yet.
So go ahead, Coach.
I'm not going to try to convince you that it's a very real thing. All I'm doing is explaining what the consequences are. Now, you can accept it or you may not accept it. Apparently, you don't want to accept it. Fine, I'm good with that.
Can we hear from Press Dawn?
The part that demystifies it is the fact that the time travel that you speak of is happening regardless of if the observers experience it differently, because it's just time is going from this moment to the next moment. The only difference is those reference frames are experiencing that passage of time at different rates. So it's not like time travel like in the movies or anything like that. It's just time is being experienced differently for two different observers.
If I get in a machine, I don't care what kind of machine it is, just because it's a rocket or whatever. If I get in a machine for a period of time and when I get out, more time has passed than when I was in the machine, that's a fucking time machine. You can try to redefine it and put semantics on it and talk about reference frame and get us all lost in what that means, but that doesn't change the fact that you are talking about fucking time travel.
Yeah, okay, that's fine. It's time travel going forward. You can never go back. I mean, not like in the movies where you pop yourself in a little room and you can go back in time or forward in time, go forward in time and come back. That's not what time dilation allows you to do. You can only go forward. You might go forward at a slower rate than somebody else, but you don't go back.
Okay, fine. So you have one form of time travel. Got it. Press on. I think you've been waiting for a while, and I've been talking a lot, so go ahead.
Have them address the paradox of them both being younger.
Explain what you mean.
That's not a paradox.
I alluded to that a little bit earlier, Brandon. What that is that in special relativity is that if you have one observer, one person, say, moving relative to another, then this is what we mean by relativity. What special relativity is you have two people, A and B. Let's say A is in the laboratory and B is moving. Okay, B is moving along, but from B's perspective, he's standing still and he sees A moving. You can't tell the difference. It's symmetric. If A appears to be moving relative to B, then B also appears to be moving relative to A in the opposite direction. So hence that's where the twin paradox comes, because they both see each other slowing down in time. And there's no way to resolve it, because in special relativity, you can only be going at constant velocity. You can't slow down and come back to compare. So from the perspective of each of these people, they see, the two brothers see one brother slowing down.
All right, George, come on.
Aging at a slower rate.
Okay.
That's
Don,
the
go ahead.
paradox.
Go ahead, Don. You were getting cut off, Don, so nobody.
Is there a
heard
reason why
what you
Kosho
said.
keeps spamming this?
Yeah, I don't know what this thing proves, to be honest with you. You see the ball look differently.
Just blocking
from
out
different
other
vantage
people's
points.
messages with that bullshit constantly.
Like I said, it goes to what I was saying about if you agree, like.
It doesn't make any sense, dude. It's this. What you're showing me with this is a ball bounces back and forth,
Like
and I
this
look
is
at
a
it from the
consequence
side,
of,
and it looks one way,
No,
and then
it's
when I look at
looking-
it from the front, it looks a different way. That doesn't. That doesn't.
No, it's not.
What the
That's
fuck?
not.
And it doesn't look any different
That's not
when
what
you're
I'm
saying
saying.
post it. You posted a lot.
I'm not saying depending what angle you look at it from. I'm saying if you're somebody who's watching it, you're moving in a craft that's watching the light bounce up and down on your craft, or if you're somebody who's on the ground not with the craft, both observers are experiencing that light traveling at the speed of light, but both those observers are experiencing that light traveling through different paths, different amounts of space. So for that reason, they're going to experience time very differently.
No, no. That last sentence right there was the bullshit that I'm talking about. So the light gets to you at different points in time. You have an optical effect that is different for the observers. That does not mean you're fucking traveling in time.
Can you not hear me, Brandon?
Yeah, go ahead, Don. Sorry, you got cut off a couple times. Go ahead.
I was trying to interrupt a lot. Could y'all not hear any of that?
No, it was like going in and out. I was trying to give you a chance to speak, but it was you were cutting in and out. Sorry.
This whole thing is like everyone's saying like the supposed agreed upon shit. It's all trying to back up the original premise, right? Of like, there's no experiment that can be done to tell the difference. What Kosho just went on about is one example of supposedly why you couldn't tell the difference. First of all, I don't buy this example. This example's fucking bullshit anyway, because the way the light fucking behaves. But regardless, fucking, it all comes back. The reason that there's the twin paradox, you can't tell which one is moving, then so therefore they should both be younger. That's all tied to this premise. If you look at all this relativity shit, all this to Newton and Copernicus or who the fuck ever, Aristotle's, they're all going to talk about you can't fucking tell the fucking difference from these reference frames. All you got to realize is they're trying to hold up that bullshit fucking premise, because this is the fucking experiment that would tell the fucking difference. All of a sudden, you'd start to see one thing aging at a different rate. You'd be like, oh, that was the fucking one that's moving. It's all a fucking Star Trek that they're trying to fucking sell you. It's on a faulty
George was trying to.
Yep.
That's not the case. No, it's not. No, that's not right. Well, but the reason why in general relativity, people have to accelerate in order to come back to their person. And by that fact, the person accelerating is obviously going to be the one who has a slower time or less time. But in the case of two people, neither of them accelerating, but both moving at a fast speed away from each other, it's true that from either one's perspective, time is less for the other person. But in that case, they have no way to communicate that to each other because they're both moving away from each other, and light is a constant that's going to be ever between them. So there's no way for them to communicate to each other to see who's actually experiencing less time. In order for them to do that, one person would have to accelerate and return to the other one, in which case you would enter into the realm of general relativity. So that's why that paradox exists, but it's not really a paradox. It's just they're never really able to communicate. They're not able to communicate with each other.
It's like talking to someone who has played Dungeons and Dragons for like 20 years straight and has this whole lore built up about this fantasy world. That's what it sounds like when you guys start talking to me about this shit. I got to be honest. It's just, it's total dogma.
If it wasn't for the evidence,
Brandon, why do you want to go down this path? Nothing gets resolved. You don't accept it. You don't accept special relativity and the consequences. So why even pursue it? You're not getting anywhere.
Yeah, because George, one thing you have to do first is actually get a person to go at the speed of light. You're working from a bullshit scenario to begin with.
You don't.
No, you don't have to.
It doesn't have
the
the speed of light.
All you have to do is go at an appreciable portion of the speed of light, like say half the speed of light or 3/4 the speed of light.
You can break your scenario down and you can fragment that into small parts of time. How about if I travel around the world in an airplane and I come back? Shouldn't that be a portion? Shouldn't I have
this test has been done?
Coach, you know the premise was you can't communicate the information because of the cap speed of light. So that's why you have to fucking recognize. Fucking recognize, bro. It's all fucking tied together, bro.
Yeah, that's why that's special relativity. That's why when you accelerate, you enter the realm of general relativity, which you still get time dilation, and you will be able to experience that. But what the other guy was saying, the airplane thing has been done. That was one of the first tests that was done for time dilation.
Sorry to put a spanner in the works, but you just can't travel that fast.
It wasn't. If you travel on an airplane,
nowhere near.
Yeah.
Nowhere
near. An airplane
You don't have to travel near the speed of light to experience time dilation. It occurs at all.
Hey, Kango 24, shout out. Thank you very much. Did watching civilians going to space yesterday help shake you guys from your ridiculous delusion that space is fake? Oh man, how many people will it take until you admit space travel is real? So yes, there's area above the Earth, and the atmosphere gets thinner as you go up. So there is space. There's I don't think anybody actually denies that there's space. What we deny is the ever expanding explosion of matter into a vacuum that you purport we are surrounded by. So there's a slight difference there, and you might understand us more if you, I don't know, listen to what we were saying and thought about what we're actually saying instead of coming up with a new straw man every day. But I do appreciate the super chat. Thank you very much.
Small differences in time intervals, so we don't have to go at these enormous
fastest thing they're detecting with their detectors that we can prove how fast the speed is on Earth, like with an actual object.
Well, one of the most amazing evidences actually is the observation of that multiple supernova, the supernova that was lensed, because they had to use
what is the fastest thing on Earth?
Had to use the gravitational lensing.
Can you guys
they
hear?
also had to use simulation in order to predict when they were able to see the next iteration of that lensing, and they got it correct.
The question was not that. The question was, what is the fastest thing, or the fastest speed a human can go, or what is the fastest thing on Earth that we know?
There's no limit. There's no limit to the fastest speed. It's near the speed of light.
Chinese pizza would be the limit.
Hold on a second. There's no limit to the speed humans travel.
Yeah, there's no limit to the speed that you can travel.
That we detect on the planet for the fastest.
Oh, don't say that. That's ridiculous. Of course, there's a limit. The ultimate speed.
But there's a limit. There's a speed limit. That's what I said. That's exactly what I said, George.
There's no limit.
Oh no, I said there's no limit except for near the speed of light, and then he said something again. I said no, because he said the limit to people. I said there's no limit. I just repeated that part, but I said near the speed of light. You can't. Nothing can travel faster than the speed of light, and we can't even reach the speed of light. But we can get close to the speed of light, and nothing would happen to your body. It wouldn't be, fucked up or anything.
What thing are you detecting?
It's just acceleration. Acceleration is what your body can't stand.
Object you detect that moves the fastest is what I'm asking you. What's the fastest living object that can move and stay alive while moving the fastest?
Well, humans have probably gone the fastest because we were on the Saturn V when it came back from the moon. 25,000 miles per hour.
No. We don't want goofy made up shit. We want actual. You can
The
see
fastest
from
thing is
25,000 miles an hour. How fast
first
can
thing
we
is 300
go
miles
on
an
the
hour.
fucking planet we live on? In reality, Dr. Seuss Kosho.
I saw humans yesterday going.
A hummingbird's wings at 300 miles an hour.
I don't hear any speeds.
G-force stuffs up the whole thing, man. Have you seen what happens
Because
to
your
their
question
face?
doesn't make any sense, Demok. You hardly ever make any sense.
So you not knowing any answers ever makes me not make sense? Okay.
No, your question is ill-posed. It doesn't make any sense.
No,
Kosho has told you, humans have
idiot.
traveled
I
up to
understood his question.
25,000 miles an hour. In principle, we could go much faster as we improve our technology.
Hold
On
up.
Earth,
Wait a
probably
minute.
the fastest we've gone is just around Mach 1. I think we've gotten close with land speed records that's getting up that close.
The world record is 2,500 miles an hour on Earth. Without NASA bullshit, it's 2,500 miles an hour.
It's pretty fucking fast.
So, right. It's a good speed. Nothing wrong with that. So that's the speed we have to work with. So what does your calculation say about that speed, George?
What do you mean? What calculation?
Your speed of light calculation.
You mean what the contraction would be?
Yeah, if that's the only speed, that's the fastest we've got. That's what you have to work with, right? That would be your duration, right?
Well, no, I mean, on the Earth, yes, but we don't have to be on the Earth. We can have a plane, a jet in the atmosphere going much faster.
How fast can a jet go in the atmosphere?
Well, let's see. What's the Blackbird gone? What was it, about Mach 3, Mach 4, Mach 4?
How fast is
6 or 7, actually. Let me see.
What's the most G-forces that a human can withstand? And also the sound from a rocket that's why you have to stand back so far, because the sound would just crush all of your organs. Are there really people on those spaceships going up? I don't think so.
No, you're right. It's 3.
The sound, the disturbance in the atmosphere is caused by the exhaust gases that are coming out of the combustion chamber. That's behind you. You're going up. You're ahead of that in the space capsule.
How many forces are they under to get up to the speed that they're said to be going?
I think on average about 3 or 4 G's.
You know what happens to someone when they're going 2 Gs, man? It wrecks their organs.
No, it doesn't.
No, 2 Gs doesn't. No, fighter pilots can pull 3, 4 Gs.
You can have a roller coaster that exhibits about 4 Gs pretty easily too.
2 Gs they're only for about 5 seconds or 10 seconds.
No, the lower the time will be about when you're approaching the 7, 8, 9 Gs. That's when it needs to be a low amount of time. But when you're talking about 3 or 4 for people that train for those Gs and understand how to control their breath, it's really relatively nothing.
Yeah, I was on an amusement park ride that did 3 Gs for sustained periods.
Yeah, there's one here in San Antonio, Fiesta, Texas. I think it's called the Poltergeist, and it immediately within I think they say it's a second and a half gets up to 60 miles an hour. I think it's something like 3 or 4 Gs, and it's about 5 seconds you're doing it, something like that, maybe less.
This one was a centrifugal flight simulator. So basically, what you did is you had a screen in front of you, and you would sit in it, and it would spin your ass up in a short base turn radius turn, and they'd run you at 3 Gs, take off, and stuff like that.
Yeah, I was wrong. The fastest is a NASA thing. It's 9.6, but the second fastest is the X-15. That's 6.7 Mach 6.7. So Blackbird's like Mach 3, 2,500 miles an hour. 3 point something.
And then what
Anyway.
is this? Is this how fast people can go, or is this how fast we can send a machine? Because you also have rockets, like ballistic missiles and stuff. So what are we trying to
Well,
test
we were
with it?
trying to We were trying to exclude NASA. That was the original question, to take NASA out of it.
But to do what?
It may be
I
the
don't know.
fastest speed a human has.
Just
traveled.
to answer a question that was posed a little earlier, is at 2,500 miles an hour, what kind of effect would that have, say, on the time dilation contraction? It basically works out to 4 parts in a million. So it's pretty easy to detect using modern technology, modern instrumentation. 4 parts per million is a piece of cake these days.
Hey, how's it going, guys?
What's going on?
I'm thinking like the Go Fast rocket. I don't know what the top speed on that one was, but I would think that one you could carry a reasonable payload on, like for a cesium clock or something.
A cesium clock isn't going to prove the concept. It's just going to show that the cesium clock will be different. It'll be affected by the travel.
By the what?
By the speed, I guess. If that's the only thing that changes the speed. I don't know why.
Well, there's all sorts of forces working on the clock itself. What's the clock made of? Is it under some type of pressure? What's affecting it? It might not just be what he's saying.
No, we know that nuclear processes aren't affected by temperature, humidity, forces, and things like that. It's a nuclear process. That's what a cesium clock is. It's very precise, and it's a nuclear counting effect that's going on. It has there isn't anything that physically affects it.
Well, we don't know what's affecting it, actually, George. All you know is that you witnessed a phenomena, and then you said that it's due to time travel. That's the leap that I have a problem with.
Fine, you got a problem with it.
Well, I just would love. I would love it if you'd acknowledge that it is a logical leap.
Well, I mean, wouldn't we be able to test for this? Like, you vibrate the damn thing. If it gets wrong time, then you know it's vibration, or you control for vibration. What are you saying is causing?
Sorry, did George just say atomic clocks aren't affected by temperature?
Yeah.
Really, George?
Or any other forces?
Yes, really. It's an atomic process, nuclear process. I mean.
Yeah, but wouldn't the electronics in the unit have to be? Manny, stop it. Wouldn't the processors and stuff in it? You'd have to control the actual device itself's temperature. I'm guessing that they keep it at 70 degrees when they're doing it.
Okay, here we go.
That's
Although
doable.
atomic clocks, shut up, Moyak. Although atomic clocks have very low levels of frequency instability. Although atomic clocks have very low levels of frequency instability, they are nonetheless sensitive, albeit slightly, to various environmental parameters, including temperature, power supply, voltage, DC, magnetic fields.
What you're talking about is the electronics that is processing. I'm talking about the nuclear process in the cesium atoms that is being detected. Now, of course,
But you're
when
not going to concede, I know.
in any electronics,
off, George.
you can have
Your old
temperature effects in electronics, but that's not what I was talking about.
Wow, Jeremy, that's what I just said.
Anyway, my point is, you haven't isolated the variable that causes the change in the clock.
Well, we can control temperature, can't we?
No, here's the thing. So maybe that's not even what I just said. It's that you took this clock at high speed, and then you notice there's a difference between it and the control clock. And then you made up a story about what that means.
No, we knew ahead of time and we expected it, and then the story checked out. That's how it actually happened.
No, that's not how things work.
There's a story that made a prediction. You ran an experiment that follows that theory, and then it validated that prediction.
Well, I'm going to make up another story, and then it'll validate that story, and then how are we going to figure out whose story's right?
Well, as long as that story actually has
theory. You need to come up with a theory, and then you need to run an experiment. We support exactly what you'd like to do. So please do it, and then present it, and then we will look it over. Please do.
I'm still
Yes.
puzzled,
That is wrong.
Brandon, where you're headed with all this. Why you keep beating on this time dilation and length contraction thing when you. Well, what's the end game here?
Because you goofy fucks believe in time travel. Fucking science.
Relativity
Fine,
explains
fine.
it very
I
well.
accept it. You don't. So why don't we discuss something that's meaningful that we can come to a conclusion or a consensus on?
Okay.
We know you accept time travel. You live in a fantasy land.
Right. With your
whole
physics and your
point-
mathematics of gravity, you can travel through time. That's insanity.
So I basically I put forth, we know that temperature can affect it. We can control temperature, right? Can we
I don't know.
control
George,
magnetism?
5 minutes ago, George told us temperature didn't affect that atomic
He
clock.
said he was talking about the nuclear process.
So,
I
George, let
was
me hear you
correcting
say
George.
temperature. Let's hear George say temperature does affect an atomic clock to clear it up for the audience.
Jeremy, I've already told you, I hate playing these games with you. I said
Just
the
say it
nuclear
to clear it up for the
process is
audience.
not, Jeremy, let me speak. I said the nuclear process, which is the timing mechanism for the clock, is not affected by temperature and other physical parameters. Now, if you're going to try to build some electronics around it for doing your displaying, then of course the electronics are temperature sensitive to some extent, but we can build electronics to compensate for temperature changes. And like I think it was Moyak said, you can put them in a temperature controlled environment. We can control the temperature within a vessel to a millidegree.
Yo, this is a lot of words to say. This is a lot of words. This is a lot of words to say that atomic clocks are.
It doesn't matter. We can control the environment in which the electronics are in.
Are you ever going to stop talking?
That the parameters in the environment are rendered insignificant as far as affecting displaying or giving a readout of what the atomic clock process is doing, what the nuclear process is doing. So you always
Okay, that was a lot of
games,
words.
these
Hold on,
gotcha
guys.
games, Jeremy,
Hold on, guys. I waited a long
that's
time for him to
ridiculous.
finish talking, so hang on. Okay, that was a lot of word salad for someone to say, yes, atomic clocks are affected by temperature, Jeremy. That's all you need to say. Say it.
And we can control it.
Say it, George. Atomic clocks are affected by temperature. Why won't you just say it?
He did say that. He did say that.
He said a whole bunch of word salad.
I know.
He said a whole bunch of word salad, and he didn't. And all he needed to say was atomic clocks are affected by temperature.
That is
I
what
was
he said.
wrong. When I said atomic clocks weren't affected by temperature, I was wrong, and they
That's what
are.
he said. Jeremy, you misunderstood. There's a process that's occurring inside the atomic clock that is separate from the electronic equipment. There's a nuclear process occurring that is separate from this electronic equipment. It is still within the atomic clock. You are correct. The atomic clock can be influenced by these parameters. The actual nuclear process occurring inside the atomic clock is not affected by those parameters.
It's all your obfuscation bullshit. It's all your obfuscation bullshit. You wouldn't just concede he was wrong when he said atomic clocks aren't affected by temperature. Fuck off.
Jeremy, you're playing a game here. You're trying to say, oh, he was wrong, when he explained exactly what he was saying. And it also gives more information about the process. So you're trying to find out that, oh, it's affected by temperature. Oh, golly, it's going to be a problem. No, you control the temperature. There you go.
It doesn't even matter. I'll even grant you that you can control the temperature and that you can control all the other variables. And the only variable that's changing is speed. Still doesn't mean that you're going to experience time slower if you travel at near the speed of light. And that less time is going to pass for you.
The whole point in this conversation, what do you know what the whole point of this conversation and all of these equations is? Because the heliocentric model claims that when you look up at the sky and you see the stars and they're trillions of miles away, you're saying you're looking back in time. And that's what we don't agree with.
Well, that's actually evident right with a light bulb across the room. It takes time for that light to get to you.
No, it doesn't.
Yes,
it does. That's how we do measurements.
You turn it on and nah.
Yes.
It's as simple as this. Do you have any evidence that light is traveling instantaneous? Do you have any evidence of that?
Seems fast to me. I didn't see it move.
Yeah, he flipped the switch and he saw it right away as soon as he flipped the switch. Therefore, it's instantaneous.
That's not my argument, though. My argument is that you've added a story on top of an observation that you've made.
And that
See,
has
I'll
nothing
even
to do
grant
with
you that
time
it's an
dilation.
experiment, and you haven't proven that if you go near the speed of light, you're going to experience time slower. That you're going to time travel.
That's true. You're right. But the problem is that what we have proven is that with speed, every time we test it, the more speed we test, the formula holds. The theory holds. Now, maybe when you get to half the speed of light, all of a sudden it changes and no longer holds. But right now it holds.
Well,
No.
I don't know. There's a big difference
Don't
between
make that
saying that
mistake.
things are
Half the
affected
speed of
by
light, it might
speed.
not hold.
Well, I'm not
that
saying that's
you're
likely. I'm just saying
I mean, we
you
have
could
the
make
new
that argument.
mesons that are traveling near the speed of light, and that confirms it at speeds that are near the speed of light. So there is no discontinuity within the realm of velocities.
But are we is with that, or do we have any method of timing, like in the what do you call it, in the Large Hadron Collider? I don't think there's any way that we could see whether time dilation happened in the individual particle that was going through there, right?
You can measure half-lives. That'd be one methodology behind it.
Okay, so if it had a half-life,
What George said is that the meson. Yeah, the meson shouldn't even survive long enough to witness it. Is what he was saying.
Okay, I'm sorry, I'm ignorant.
So time affects these speed affects these particles. It doesn't mean time travel.
The only observation of the speed of light is lightning or plasma, and it is emitting light, but it's a traveling entity. It's plasma. That's the only evidence that you can see how light moves. There's no other experiment.
Come on, got lasers. We can time lasers. Jesus.
Turn it on.
They
measure it over a meter, and you find out that it traveled that meter in 1/2 millionth of a second. 200 millionth.
Yeah, they measure distances with the speed of light. So
Yeah,
like regular
if
carpenters do.
If you look up slow-mo guys, they have a camera that's an incredible frames per second, and they are witnessing from the source a laser light going through a water bottle, and you can see the light traveling. At the very least, that confirms that light isn't traveling instantaneous.
No,
What's the site?
That's the shutter speed. It has its limitations. That's not the light moving. That's the shutter speed. Can't keep up with it.
Oh, come on, Carlos. Come on.
It is
even children can understand this concept that light has a finite speed. It's not instantaneous.
George, you spent a whole day
for hundreds of years.
George, you spent a whole day and whole day. You spent a whole day. Hold on, Bio. George spent a whole day once trying to convince us that he measured the one-way speed of light. You think this is the right person to be having this conversation with?
Well, what's your confidence level when it takes time to travel both directions, Jeremy?
Logic. The thing that you guys are forgetting that light is electromagnetic radiation, and we have measured the actual speed of electromagnetic radiation with radio frequencies with radar. Like, how do you think all of that actually works? Time of travel, time of flight when it comes to freaking Wi-Fi. It's like how Wi-Fi actually works.
Hold on, please. The argument there that they're trying to play is that there is among the most philosophy-tarded people in sciences that you can't know the one-way speed of light for absolute sure, meaning you know the round trip time it takes, but you can't prove 100% that it took or that one way didn't happen instantly.
How do ring laser gyroscopes work?
So
that's a good question, Branch.
It's the same material coming back at you. It's light. It's a photon, whether it's reflecting off of something or whatever. It's still light, so I don't know why going one direction would have a different speed than the other direction, but that's the
there's a difference
one direction you might have.
There's absolutely a difference between natural light and man-made light. Can you think
No. Absolutely no difference.
What's
the difference? It doesn't matter how you generate the photons. A photon is the same, no matter whether you comes from a candle, a laser, or an explosion.
Let him expand, George. We know he's wrong, but let him expand. In what way is it different?
Well, man-made light is definitely going to be different than natural light. Natural light has
Why?
so many more properties to it. You can't
Name
recreate
one.
natural
We
light.
can't
Can you?
Name
duplicate.
one.
We
Hold on.
can't
Natural light.
duplicate the light from the sun.
We can
Name
make a
one.
Can you
laser. We
recreate
can make a
the
laser
natural
that's
light?
Just name one difference. I understand you're saying they are different. There are properties that are different. Light, natural light versus laser light is different. Please name one way in which the properties of those two sets of lights are different.
One was man-made, and you can't recreate natural light. There you go.
Right,
No,
these
there's
are
no
not
difference.
properties.
Sure
These
you
are not
can.
properties.
Natural light is just a combination of several wavelengths of light. And all we have to do is measure, say with sunlight, find all the frequency components, which we know of, and the intensity, relative intensity of those components. We can put them all together and create natural
Okay,
light.
so you get natural light, and you put it in a bottle, and you can see what it's made up of. Can you?
Oh man!
All the
You use a
frequencies.
spectroscope,
God.
spectrometer.
Which is
So-
a man-made device,
did
which
you
you
dig
only
up
can
this?
be able-
Wow.
It measures wavelengths. It measures wavelengths, the electromagnetic wavelengths of light.
Okay, so
What
you're
makes
looking
you
at the
think-
magnetic fields, but what else are you looking at?
Holy shit!
Dude, that's
Can you
what
show me
light is
any
made of. Natural
practical
light
difference?
is made up
There's
of.
no point talking to this Carlos. He's a Poe. I mean,
I
he's
just have
just
one
trying
question.
to.
You have to admit there are limitations. You have to admit there are limitations to what we can
What?
measure in light.
Like what? Oh, there may be, but at this point, show me if
you
I make a
can't
natural light,
duplicate-
if I make a man-made light and I try and grow a plant in it, the plant will grow the same rate it does in the sun.
Bullshit.
If I match the sun's
Bullshit.
frequency, it'll grow the same
Bullshit.
rate.
Bullshit. You cannot duplicate sunlight with artificial lights.
How do
I use-
hydroponics work?
We use lights, but they don't work as well as sunlight. It does not work as well as sunlight. The
Bullshit.
sun is always growing. Bullshit. Okay, you're gonna tell me
Bullshit.
about growing with lights versus
So,
growing with
Carlos,
sunlight. You're gonna
I
tell
wanted-
me that artificial lights can do better than sunlight?
Yeah, and under certain situations, yes, of course. Carlos, I just have one question. If there was two light sources pointed at you, and you didn't know what the source were, how would you differentiate between them being natural light and man-made light?
Or one's probably going to make me sick, and it's not the natural light.
Oh, please give me evidence. Go ahead, timestamp.
Well, have you ever seen a photon?
No.
Well, the premise of your light theory comes down to a photon, doesn't it?
So
I mean, all you ever see is photons.
Yeah, if you're seeing something,
Strange
you're
question.
seeing photons.
What kind of sick though? Like, does sunlight give you diarrhea or some shit?
Okay, so the moon. You know, you can get solar energy from the moon, right? You can put on a solar panel, get solar energy from the moon. There are light sources that humans can create that can make much more light than the light you receive from the moon. So, from a solar panel, and the solar panel will still accept energy from that source. So there's no difference in photons from it being naturally made or man-made or whatever. It's just whatever's emitting that light. You know, whatever elements or whatever emitting that light is going to determine the wavelength. But other than that,
Well, we still don't understand why in the moonlight it's colder in the moonlight than in the moonshade.
Yeah, we do understand that. We do understand. We understand it's not happening.
Do you?
You haven't heard the answer?
Moonlight is not cold.
Have you heard the answer why that is, or why we see the lower temperatures?
Yeah,
During
tell
those
me.
tests,
Inform me.
It's a localized weather system caused by cover, where you have radiant heat bouncing back and forth and being insulated from returning out to the great beyond. And you can
Basically, it's just
good.
It's just those tests being conducted badly.
You don't need to have cover to have a shadow. You don't need to have a cover.
Really?
That's a patently false claim. Yes.
So where would there be any kind of a localized environment?
Will a
come from the shadow
vertical wall?
from
Will
a tree in one direction?
Will a vertical wall block moonlight without being over the top of something?
Is it still blocking it from a direction? In other words, will radiant heat still be bouncing back from the wall to the position?
Yes, and our claim is that in the shade, it's actually. Oh, okay, interesting.
Yes, you have a localized environment even with.
Well, you can actually though, but the part that's shaded doesn't have to be next to the wall. It could be some distance away.
Show me that. Show me a shadow, some 150 feet away, causing a temperature change.
Yeah, when those tests are done correctly, or under ways that would kind of make sure that it's not something else causing that, you don't find the moonlight to be colder. Like the way that I did it, and I suggest other people to have done it, is to use a clear box, 2 clear boxes, and cover one of those clear boxes with black construction paper or something, and use a glass of water. You start out at the same temperature, and put both of them out in the moonlight. So that way, the fact that they're in the boxes are going to make sure that there's not anything else, affecting their temperature, and the fact that you have it in those boxes and not underneath a shed or underneath a tree. Make sure is that the temperature is not caused by, the proximity of, whatever it's under.
Yeah,
because really
Brian
yeah,
Mullins was setting that exact same shit up, right? And then he set it up, but he didn't actually show anybody the results.
When you do this, you want to make sure that the coins are as close together as possible, but you want to have the shade being created from something very far away so that it's not trapping any of the heat in or anything,
That's why I said. That's why I just said do it this way, because in this way you've isolated every other variable except for the sunlight, the moonlight, because of the fact that you yourself have put both of them in these boxes, and they're both out in a field or something else away from the house. So whatever would be causing the temperature, whether it's like under a building or near a building or whatever the shade is not going to affect it in any way, because they're both away from any kind of building or structure or anything.
Kosha, how would the moonlight hit the water if it's inside of a box?
Clear.
It's in a clear. They're clear boxes.
A plastic, like plexiglass box or something.
Yeah.
That wouldn't work at all. You need the moonlight to hit it.
Yeah.
You can't go through.
Exactly. I don't know if you know this, but
wait.
You don't want to go through.
You can do is you try this during. You can test this out during the day. You can test this out during the day with the sunlight and do the exact same test and see which one of those heats up, and it's going to be the one.
That's the whole claim, is that moonlight is different than sunlight. That's the whole claim.
I know.
That moonlight is different than sunlight.
The test that I said about the sunlight was just so G-Love could understand that.
Well, you're trying to compare apples with oranges.
Hold on. If you can look at the moon through a sheet of plexiglass, how is it that moonlight can't travel through plexiglass?
I'm not saying none of it can't travel through, but you're not going to get an accurate test if you have some material between the thing you're trying to test. It's just not a good way to do it.
The test I would go for is I would take an umbrella essentially, and I would set it down low to the ground, and I would angle it so that the moonlight gets underneath it, and you'll see that the temperature is still higher because the umbrella will shield will create that microenvironment.
Yeah, there's a lot of ways to
using
do this.
one of those electronic thermometers too that judge the temperature by color, because evidently they're tricked by certain wavelengths.
What about just doing a thermal camera at the moon itself?
Yeah, that shows heat
or colors.
Greater Sapien.
They do it based on the color.
Greater Sapien actually did a recreation of the experiment, actually taking into account the variables and did it actually correctly. I can share that video where he actually did this experiment exactly and showed the exact same temperature.
Share it. Because I'm not convinced on this one either. I remember
the
Anthony
other
did this.
thing you can do is take the umbrella and do it on a moonless night, and just set the umbrella up, and you'll see that it's warmer under the umbrella.
I think that was one of the tests he
Behind the
did for
house.
control.
Yeah.
That was one of the tests he did for control.
Aren't there special properties to moonlight other than that, though? I don't know very much about this subject.
That's the thing.
Like it
in order to
causes
say plexiglass is in order to say moonlight is affected by plexiglass, you have to say how it is affected by plexiglass. If it's not going to be a correct experiment if that's the case.
Well, no, you wouldn't want to do that. You wouldn't want to put anything in between because that would be a filter of some kind, just like sunglasses filter.
Right.
Out.
Yeah, but it's meant to be.
Yeah, but both
it's meant
are
to
going
be a filter from the atmosphere. Yeah,
I get that, but
that was
there's
all
got to be
part
a
of
better way to
putting
do
the
it.
box.
There's got to be a better way to do it than besides sticking
somebody
a
said
piece
an
of
umbrella.
plastic between you and the sun. Yeah, the umbrella might work, but doesn't moonlight also like cause decay, and it's better for planting crops in, or is that just some correlations that have to do with?
It behaves the same way the sun does, except for like if you have a solar panel that would accept 3,000 watts per meter during a noon of the sun, then it would accept 10 watts from a full moon. In this, from the same angle or whatever.
Which is
Or full moon.
coincidentally the same amount of luminance difference there is.
Yeah, I get it. You guys
It
are saying
behaves
it's
the
just
same way the sun
the
does.
same light, but we've heard these things before that it causes decay.
Yeah.
And
have you seen it?
And no, I'm asking if anybody has.
As
anything
far
about
as I understand, there's no increased decay. In fact, sunlight will make things rot a shitload faster than leaving something out at night. So I'm sorry, I'm gonna say that sunlight is probably worse for decay.
It's the opposite.
Well, that's what I'm saying.
Sunlight is preservative and antiseptic. It's why you like dry fruits and things in the sun, whereas the moonlight is generally more septic and putrefying.
That's what they say, what I've heard said, but it's not anything to bear it out. And I know that a rotting skunk out in the driveway in a sunny day will fucking putrefy a lot quicker than one that sits out in a cool evening.
Right. This is one of the easiest testable things that can be done. And especially with what you said, with a grape. Put a grape out in sunlight for 12 hours, put a grape out in moonlight for 12 hours, and then record the decay process at the end of each. It's an easier thing to demonstrate.
Wouldn't that be more tied to temperature, though? Right? Not necessarily night or day, because you could put it in the sunlight in the middle of winter all day, and it.
Right? No, you're 100% right. Yeah, there will be other things that will affect it as well. But in the blanket statement that the moonlight causes more decay or whatever the fuck, that's easily testable.
With another blanket statement that's not considering anything else like temperature.
No,
you could do
the effects of the because it is a blanket statement of these materials out in sunlight, these materials out in moonlight. Those have connotations of yes, temperature is going to be lower and there will be lower energy. But if the cause is moonlight, then you're testing it in the moonlight. There will be other factors, of course, but that'll at least eliminate that blanket statement.
Well, they dry fruits in the sun for a reason as well. I mean, of course,
yes, because the heat drives the moisture out. You can dry them in your oven.
I hear you, but I don't think that's the only factor. But I hear you.
No, that's really the only factor. Dry it, put them in your oven, and you set it to 150 degrees and leave it there all day. And you'll have dry fruit at the end of time, and it'll be just as good as sun-dried fruit, if not better.
There's got to be some experiments that universities or somebody else has done, related to moonlight, right?
I will say the moonlight is not cold, though.
Yeah, well, I'm not too worried about it being too cold. I don't know what difference it makes either way. It's just a claim that was made somewhere along the way.
Wait, hey, Brandon, if moonlight is cold, why not go out with a magnifying glass and focus it on your thermometer and really cool it down?
I've done it.
Yeah, right. And
you're probably
I've done it with a convex mirror, and actually warmed. It was warm light. So, yeah, that debunks that.
So what was that? About a 400 or 500 times increase of moonlight. So what was the temperature change for 500 times the amount of moonlight?
Well, you guys out there, you should do this.
Magnified moonlight.
Get yourself a magnifying glass and do this. We told Arwen to do this over a year ago. Go out and freeze ants with moonlight.
Well, George, he claims he did it, so I'm just wondering what his findings were. Was there a 500 times increase in the cold?
I used a convex I'm sorry, concave mirror. So it's, I was saying using a magnifying glass, they would people would claim that you're blocking some sort of wavelength with the glass or whatever. So that's why I use a concave mirror, and it was actually
Well,
warmer.
recombinance-
Huh?
Oh, yeah, that's expected. You'd expect it to be warmer because you are
I had
concentrating
Even better
three,
not
400
using a
times.
mirror, because a mirror will not discriminate, like Carlos said, going through glass. That's the whole idea behind the Newtonian telescope, is that you don't end up with aberrations because of going through glass,
Even,
and,
you know.
wavelengths being affected differently with indexes of refraction and all that.
Right. Yeah, and it doesn't block out infrared light or anything like that. So, but
Exactly.
yeah,
It's just reflecting back what it receives. So yeah, using a convex mirror would be or concave
Ideal.
mirror, I mean, is a much
what was
better way
funny
to
is
do this.
what was funny is that the rock that I had under the shade was a little bit warmer because of radiator cooling. But then of course the one that was with concentrated moonlight is actually warmer. So yeah, that's because nobody does the next step, which is actually concentrating the moonlight, because everybody goes and blocks the moonlight with actually creating a cover, so you don't allow radiator cooling. So people think that that's actually making it cooler.
Yeah, plus anything you put on top of your thermometer is you'll get radiated heat off the soil of the earth being trapped in under there, and it's ridiculous. I mean, if you really want to accelerate the process, you got to magnify it and do what Carlos did. Get yourself a convex mirror, concentrate the moonlight, and see if it warms up or cools down your thermometer.
I gotta say, I feel like this one has been debunked. Really, I really haven't seen any evidence that moonlight is cold.
Well, it's plenty of points bouncing around with even glowbusters. So there's that.
I know. Yeah. Hey, but the moon does do some weird shit. It causes some strange effects. You guys have heard of what is it, sundowner syndrome? Where old people in nursing home on full moon.
That I could buy. There are biological effects, but I don't know if it's cycle or it's actually the moonlight itself. But some animals breed during the moonlight and stuff like that, so you might have some biological effects. Some people, women or whatever, they may be somewhat on the moon cycle, but that doesn't mean the moon's doing it. You could probably fake that out, or you could test that double blind by faking the same conditions inside a building, and seeing if you could trick the mind into thinking that it's a moonlit night or whatever.
Maybe, but why would the moon cause any of those things? That's what I'm curious about.
Because it's probably just fucking with your circadian cycle. It's probably just fucking with that. So when it's a full moon,
Talking about a rhythm.
There is more light out. So when your body thinks that you're supposed to be sleeping, if there's more light out, it may become more active, and then you're operating differently than normal. It may have something to do with that as well.
The menstrual cycle, though.
Yeah, to be fair,
circadian.
Your body is a clock that's constantly recalibrating. So you throw light in at night, and your body's going to recalibrate a little bit.
Why would that cause somebody's period to align with the moon cycle?
I don't know.
But it doesn't do that. It
doesn't?
It doesn't happen, though. If that happened, then women would all have the same period.
Yeah, I've heard that some people are susceptible to it.
How do you know they live together? Yeah, it's if they're in close proximity, they live together. Their cycles.
Let's get Brenda on the phone.
We need some women. If any women want to join the panel and tell us about menstrual cycles and the moon cycles,
let's get Brenda on the phone. Yeah.
Although I think on average,
you can see the populations in like Alaska and shit. The way that they operate throughout the day, it seems to be dependent on light. But when you have a lack of it, or if you have too much of it, then your body kind of gets fucked up from that.
Yeah, I would wager that you could probably accelerate somebody's schedule just by putting them in an environment, just changing when day-night cycle is. Do it by a couple of hours a day, maybe a few minutes a day.
Well, during the night, people act a little shady.
Boom.
Okay.
Yeah. Sorry. I'm here all
Anyway,
night.
I'm gonna close out the YouTube show, but thanks to the panel for joining tonight. So some good conversations. George, you took kind of a beating there. I know you can take it though. Appreciate that. And we'll see you guys tomorrow night for Friday Night Fights. If anybody wants to say anything that didn't get a talk during the show, or there was something you wanted to say that you didn't get a chance to, go ahead now.
I just wanted to say,
Earth is not
I just wanted to
flat.
say, if you can come up with the artificial light that can perform as well as the sun, you'd be a billionaire.
Why?
Okay. Anyway, I didn't get to talk during the show earlier. I just want to say one thing. Aristarchus! All right, I'm out.
Pete's not even here to hear it.
Chinese
The,
pizza, open kitchen.
I said
the whole
Aristarchus.
The whole matching the frequencies and capabilities of sunlight, I have to see something that indicates that it can't be done, because at this point, my impression is that it can be without a problem. It's just a sequence of frequencies all put together.
Well, I can tell you, you would grow trees indoors then if you could simulate the sun. You could grow tree-sized cannabis, indoors. You'd be a billionaire.
People do that.
Dude, you're telling me, Bio? Is that what you're telling me? You're going to tell me about it?
I said the words, right? And you heard the words, right?
Well,
Why does
I'm
anybody
telling
grow
you, they don't grow trees indoors. They grow
No, they
plants
don't.
indoors. They grow trees outside.
So there are
What makes
plenty,
you think that
plenty of-
sunlight would make it grow better? Why don't they just grow them outside? Why do they grow them inside? Because you can control the amount of light, the duration of the light, temperature.
Look
and
up
you
full
get
spectrum
better
bulbs.
yields.
And
Full
even with
spectrum
those,
bulbs mimic natural light by emitting the same wavelengths of light
even
as those
even
that
with all
resist from
those
the sun.
advantages, even with all the advantages of being able to control those conditions and have the longer lighting cycles, they still can't compete with growing plants outside.
Wow.
That is interesting.
Huh?
Yeah, I'm gonna close it
So
out,
everybody just
but
take on this expense.
we
Okay.
can continue this in just a minute. But I do find it curious that the globe side thinks that even the sun can be replicated with modern science.
No, it's not
There is
replicated.
nothing outside of modern science's grasp or ability to recreate. I
Just
find that
talking about
very
the light.
interesting.
Talking about the
Anyway,
light.
I will be recording when I get back. So just so you guys know, probably records all night. And yeah, I'll be back in like 2 minutes to start it. So thanks again, everybody. Appreciate it.
I'm
Yeah,
not
yeah.
sure what
Just 'cause
he's hoping to
Groundbreakers
get out
believe
of
in
that.
science.
So
Are
the
you replacing the
intensity.
sun?
All right. Thanks everybody. I hope you enjoyed the discussion tonight. We'll see you tomorrow for Friday Night Fights. Man, I'm freaking tired right now. I don't know why. Actually, I haven't been sleeping that well. I keep waking up in the middle of the night for some fucking reason. But anyway, you guys have a good night. We'll see you in the morning. In the morning, Jesus Christ. We'll see you tomorrow night. And yeah. See you later.